Check, check. Mic check, check. Dear participants, kindly switch off your mobile phone. It's going to arrive. Good morning to one and all present here. I wholeheartedly welcome you all. The second day of ANFR sponsored Indo-South Korea, Thailand 5th International Conference on Nanoscience and Nanotechnology for Energy, Environment and Biomedical Applications. Jointly organized by Vinayaka Mission's Kirupananda Variyar Arts and Science College, a Constituent College of Vinayaka Mission's Research Foundation, deemed to be University, Salem. A core facility center for photochemistry and nanomaterial, Research Institute for Advanced Chemistry, Gyeongsang National University, South Korea, Department of Chemical Engineering, Chulalongkorn University, Thailand, cordially invites you all for the iNEEBA-2025. May I invite the chairperson of the session, Professor Dr. A. Rajan Samuel, sir, Director Academic from Vinayaka Mission's Research Foundation, deemed to be University, Salem. I also invite the keynote speaker of the session, Professor Dr. Surdeep Kyom. Good morning, sir. You are on the stage, sir. Over to you, sir.
Can I connect my...
Yeah, very good morning to all the delegates and the resource persons of iNEEBA 2025. Now we have the keynote lecture 2. Let me introduce the keynote speaker. Dr. Surdeep Kyom is an associate professor in the Department of Chemical Engineering, Faculty of Engineering, Chulalongkorn University, Bangkok, Thailand. He received his PhD in Chemical System Engineering from the University of Tokyo in 2004 and has been with Chulalongkorn University since then. His early research centered on applying advanced mathematical tools to improve the control, operation, and maintenance of chemical processes, alongside investigating key phenomena in industrial chemical systems. Over time, his focus has shifted towards next-generation electrochemical energy storage, particularly zinc-based batteries such as zinc-air, zinc-ion, and zinc-iodine systems. Dr. Gyeongsang has published more than 250 peer-reviewed articles and serves on editorial boards of several international journals. He is frequently invited to deliver keynote and plenary lectures at major conferences worldwide. His current work integrates fundamental electrochemistry, materials engineering, and system-level optimization to advance high-performance, durable, and sustainable energy storage solutions for large-scale applications. With this brief note about him, I request him to deliver the keynote speak on rechargeable zinc-air batteries for grid-scale energy storage, advances, persistent challenges, and pathways to practical deployment. Over to you, sir.
Thank you very much for your nice introduction. And well, I'm Suratep from Chulalongkorn University. So, well, some of you, I'm not sure, some of you may know the university. But anyway, I will start from this photo first. It's not clearly see from here, but I hope you can see from the back of the room. Wow, this is our campus. Our campus is located center of Bangkok in the BCD area. And wow, this is at the center, it's the main auditorium of our university. Okay, and this photo, of course, if you want to enjoy such a view, you have to be above the ground, okay, because this photo taken from drone, yes, yeah. And it must be during the night to enjoy the, wow, such a good view. And you see, during the night we need light, right? And our society is driven by electricity, okay? And the electricity we want must be, well, carbon free, okay? And well, to generate electricity without worrying about emission of carbon, well, you can use renewable energy like wind and solar. But the question is, what are we going to do when the wind is not blowing and the sun is not shining? Okay, when the wind dies out, so what are we going to do? So you see that we install more PV, we install more solar panel, but we cannot guarantee that we can access to electricity all the time. So the key is energy storage, okay? I can say that energy storage is a key element for effective use of renewable energy. And well, for such application, you need very large scale, right? Large capacity of energy storage, right? You generate electricity when, well, the condition allows you to generate electricity. But by the nature of electricity, you generate it, you have to consume it immediately and at that place, okay? Well, for the grid. The grid is designed for the distribution of electricity from one place to another place. So you can solve the problem of the location, but we still have the problem of the time. We have to, as I mentioned earlier, that we have to consume electricity immediately. Imagine that, well, if you have supply chain of food supply chain, you create food and you have to consume it immediately. It's useless, right? So, but sorry that we don't have such a thing like refrigerator in the power grid, okay? So energy storage do that job, and it must be large enough. So for energy storage, of course, if we think about in the viewpoint of cost, no technology can beat pump hydro power, because for pump hydro power you need two plates, right? And you play with changing electricity and potential energy, right? So if you have excess electricity, of course, you pump water back to the reservoir at higher level. And then if you need electricity, you use that water in the higher level of reservoir to generate electricity, okay? But you cannot have that kind of things in the city, okay? Because it costs large area, okay? And create other pollution also, okay? It affects our environment. So the better choice is a battery, and what we need must be rechargeable battery. You can think about the battery. It's a kind of storage for electron. You need two plates, okay, two condition, two states to store electron. So we need two electrode material, active material, and what we need is, well, if we want to design the energy storage for large capacity, we have to consider the abundance of material. So we consider, well, the left-hand side figure, which show the abundance of elements in Earth's crust. And you see that you cannot rely on rare earth, okay, or, well, elements such as gold or platinum, because you cannot scale it up in the future, okay? Even your technology is really good, but you have problem in the future because limit of material. So what we're working is zinc. Zinc, where is zinc? Zinc, I cannot show it here. Zinc is here. The good things about zinc is zinc the fourth major produced metal in the world. Oh, thank you. Yes, so now I can enjoy using this spider. Okay, zinc, yeah, zinc. The number one is iron. Of course, if your technology use iron, you will not have problem during scale up process. And aluminum is also good, copper also, but zinc is also good choice. Zinc has favorable redox potential, and it has high stability. That means, well, it will not explode, okay? And it has high specific volumetric capacity. Why? Because one atom of zinc, it produces 2 electrons. That means one atom of zinc can store 2 electrons also, okay? But of course, if you compare with lithium, lithium is more light, but one atom of lithium you can store only 1 electron, okay? Sodium is also good because it's abundant, but again, it's heavier than lithium, and it can store only 1 electron, okay? So zinc is also a good choice if we think about in terms of safety, okay? And also in terms of supply chain, because we have stable supply chain. You can access to zinc supply from various places around the world, okay? And on top of that, by using zinc, well, zinc is 100% recyclable by using existing technology. So you don't need a new technology for recycling zinc. So we have 2 configurations for the battery. On the left-hand side, well, I think you're familiar with this type of battery, like the battery in your smartphone, or even the lead-acid battery in your car. Also use this configuration. We keep on the active material inside the cell. We pack everything inside the cell. So what is the problem with this configuration? This configuration, of course, one cell is a closed system. Of course, it's good because maintenance may be maintenance free because it's closed system. But the problem is one cell has a certain limited capacity and also power. So when we are talking about large scale, you need larger capacity. So what we're going to do, if you use this configuration of battery, you multiply the cell, just simple like that. For example, one cell can power for 1 hour. You want to double the capacity, 2 hours. For example, you need 2 cells, just simple calculation like that. But the problem is, the cost go linearly with the number of cells. So for large capacity, the cost is really expensive. What about if we allow the active material to flow through the cell like this? Yeah. Why is this? I don't know. Can we remove this part? Can we remove this part? It's not on my slide, but it's okay, you try and continue my talk. Okay. Well, the active material, if we allow the active material to flow through the cell, you see that the capacity is now not limited by the number of cells anymore. Because if you want to if you want to double the capacity, operate 2 hours instead of 1 hour, you don't need to increase the cell, the number of cells. You increase the storage instead. So you scale the size of the storage tank is much cheaper, right? Yeah, that is why flow battery is preferable in case of large scale. Okay. What about the real cell? Well, this is a small single cell used in the laboratory, but this size, okay, this is for real application. You have number of storage tank, right? And also you have a cell, number of cell. You don't want, if you want to scale the capacity without scale the power, of course, you just increase the storage tank. You don't have to increase the number of cells. Okay. So in this case, for flow battery, power is independent from energy component. And the advantage in terms of capex for large scale system. And the other good thing is it has very long cycle life. Okay. So what about zinc? We are talking about zinc. We want to use zinc in flow battery. Is it possible? Yes, it's possible. But because the active material zinc is solid phase, it's not liquid phase like in case of vanadium. So in that case, we play with changing of the phase of the active material because the active material is solid, right? So during charging, zinc will deposit inside the cell. So we have limitation on the capacity of the cell again. But trust me, the capacity is much larger than in case of enclosed battery, enclosed flow battery. If you want to use zinc, okay, I can, continue talking. All right, so for flow battery, we start from zinc in solution. And when we charge the battery, what happens? Zinc will deposit inside the cell, right? And once you discharge the cell, zinc previously deposit during charging phase will dissolve, okay? And dissolve into the electrolyte again. Okay, so we call this type of flow battery as hybrid flow battery because actually the capacity is not unlimited. It's limited by the space or volume of zinc inside the cell. Volume of, space available for deposit zinc inside the cell. Yeah, but what we expect is about 200 or 150, anything larger than 100 milliamp hour per square centimeter, it's usable for large scale zinc hybrid flow battery. Okay, so I mentioned earlier that we need two active material, right? The one I discussed a lot is zinc. We need other active material also because we need two active materials. One is zinc, we have to choose the other one. Zinc will be used for the anode side, okay? You can say negative side, negative electrode, or the anode during the charging. Well, you have several choices for the cathode active material. What you want to use for cathode active material? You can use iodine, you can use bromine, you can, well, use oxygen also. I'm going to talk about the case of oxygen. So basically, the active material is zinc and oxygen. And that oxygen must be oxygen from air, not pure oxygen. Okay? So why should we use oxygen? Because oxygen is abundant. We are talking about abundant, right? Abundance of material. If we use oxygen, it's all right because you never run out of oxygen from air. Okay? If you run out of oxygen from air, we don't need battery anymore. Okay? So we use two electrodes, zinc and oxygen. And oxygen is virtually unlimited, right? And the other good thing is this system uses aqueous electrolyte. What is the advantage of using aqueous electrolyte? That means, wow, you cannot burn water. That means, wow, this battery cannot catch fire at all because the electrolyte is water, right? Okay, you cannot burn water. That means, wow, this one cannot catch fire. So during the charging, zinc will oxidize and turns to zinc ion. And in the alkaline aqueous electrolyte, it cannot be stay like zinc 2 plus like this because there are plenty of hydroxide ion in the electrolyte. So it coordinates with hydroxide ion and form zincate ion. This one we call zincate ion. It has very high solubility limit. But even it has high solubility limit, everything has a limit, right? So once it reaches the solubility limit, zincate returns to zinc oxide. Okay? So the product from the charging of the battery is zinc oxide. We play with, well, oxidation of zinc, okay? You can think about rusting of zinc. It's the same process. And what happened at the cathode? At the cathode, during the charging, we consume oxygen directly from air, and it's combined with water and electron, and it produces hydroxide ion. And this hydroxide ion generated at the cathode, we move to the anode side, okay, for the oxidation of zinc. Okay, so what happened during charging? The charging, well, we break zinc oxide and form zincate, and we break zincate ion, and zinc we deposit at metallic zinc, right? At the cathode, well, from hydroxide ion, we produce oxygen instead. And this oxygen will release to environment, to atmosphere, okay? No one blame you if you release oxygen to the air, okay? And if we look at the over potential, so you see that for zinc, over potential is not a problem at all because it has, the kinetics is really fast, okay? The over potential is quite small. But the real problem is at the cathode, where the over potential for both OR and OER is quite large. So that means we need catalysts to accelerate this process, OR and OER. Yes. So if we look at the problem at the zinc electrode, what is the problem at the zinc electrode? We have issue of passivation. Why we have passivation here? Because our discharge product is zinc oxide. Yeah. And this zinc oxide can deposit over our active zinc. And one is cover our active zinc become inactive. So we call it passive, right? Passivation issue. And the next thing is shape change and migration, also dendrite growth. All these things are, well, the same issue. because during the charging, zinc will change to the zinc cation and dissolve in the electrolyte, right? And during charging, it will deposit back. Okay, and if our zinc deposit in different location and in different form, we call it shape change. Okay, and it's migrate from the original place. And in the worst case, if the deposit zinc during charging deposit in a form of dendritic, we call it dendrite growth. So dendrite growth can penetrate through the separator, if you have separator in the system, and touch the other side, the cathode. Okay, and that is the problem of short circuit, because electron will not move to the external circuit anymore. It will directly shortcut. And the other problem is corrosion of zinc. Okay, corrosion of zinc is a trade-off between passivation and corrosion of zinc. Yeah, corrosion of zinc, this phenomena occur because zinc can donate electron directly to water. Okay, and it will not generate electricity anymore because it reduces the water instead, and water will form hydrogen gas. Okay, so that means we lost zinc without producing electricity. And the last one, zincate crossover. I told you earlier that zincate has high solubility and it can travel any place in the cell. And if it cross to the cathode and deposit there, we lost that zinc species. Okay, so we solve all these problems, this issue, by using flowing electrolyte or modified anode for passivation inhibition. Also, we use electrolyte additive. And in particular, for zincate crossover, we mitigate this issue by using anion exchange membrane, blocking the zincate to cross from the anode to the cathode, but allow only hydroxide ion to move back and forth. So we developed a technique to monitor zinc during operation, deposit zinc during operation. Then we study the influence of current density and flow rate. We have two parameters that we can use to control the form and also the shape of the deposit zinc. Okay, one is the flow rate, because this is flow battery. We can change the flow rate of our electrolyte. And the other thing is current density. Okay, so zinc has very good memory. Yeah, so it remember everything you did to the system, what have been done to the zinc. Okay, that means we call it memory effect. Okay, so you chart it at different current density, at different flow rate, it remember everything in a form of morphology. Okay, so by increasing the flow rate and we keep the constant current density, we can smoothen the deposit surface. Also, the flow of electrolyte can erode the outer layer of the deposit zinc and make it smoother. And then we can reduce the effect of the dendrite growth. And the other thing is, if we keep the flow rate constant at quite low flow rate, and we keep increasing the current density, what we found is it tends to form the dendritic. It promotes the dendritic growth. Okay, so this photo shows the deposit zinc, the surface of deposit zinc at different current density and different flow rate. Okay. Now we move to the oxygen electrochemistry. Okay, at the cathode. So at the cathode, we play with oxygen electrochemistry. That means we deal with OR and OER. What is OR standing for? OR is oxygen reduction reaction, and OER is oxygen evolution reaction. During the charging, we play with oxygen reduction reaction. You consume oxygen, you break it, okay, and you use that oxygen atom. But during charging, Okay, we break zinc oxide, right? And we form oxygen again and release to the environment. And these OR and OER are not new. Normally, well, you use it in fuel cell, okay? But in fuel cell, of course, it depends whether alkaline or acidic, okay? The mechanism is different. And in electrolyzer, you use OER, you need OER, right? Because at the cathode, at the anode, you produce the oxygen, okay? You produce oxygen, that means that it's OER. And also, you use OER in electrochemical reduction of CO2, okay? And what we need at the air electrode, the structure or configuration of the air electrode also important. Well, we look closely at the OR. You see that for OR, we consume water from liquid phase, and we consume oxygen from gas phase. Also, we need, well, pathway for electron, which is solid phase. So the reaction occurs at the three-phase boundary, okay? So we have to manage the conductivity, we have to manage the wettability of the electrode, and also porosity, because we need oxygen from outside, okay? And our system contains liquid, so we have to block the liquid from leaking out from the system, okay? So for the air electrode, it uses as physical support for the catalyst layer, because we need catalyst there, and we need high conductive pathway, right? Okay, and as I mentioned earlier, that we have to prevent the electrolyte from leaking out, okay? So what about during charging? During charging, you go this way. So for OER, it's a liquid phase only. But the problem of OER is you produce oxygen. So what is the problem? Oxygen bubble, once you produce it, it can accumulate and break your electrode. Or small oxygen bubble can corrode polymer inside, or even conductive carbon, because most of the time you increase the conductivity by adding carbon, okay? So to solve all these problems, you have three ways. First, you separate the electrode for OER, okay? Because OR requires three-phase boundary, right? But OER, no, we need very high stability, okay? Or you use multi-layer electrode with separate layer of OER. It's possible. You create two layers and pack it together. Or you need, well, you have to produce a single layer electrode where the catalyst can promote both OR and OER. Yeah, you can solve this, but again, stability is important. Let me explain again about what really happens if we use the traditional way during discharging. For a traditional fabrication, we call it non-supported electrode. We normally mix the catalyst with conductive carbon and binder, a polymeric binder, and you coat it over the porous substrate. And during discharging, it's totally fine. It can consume oxygen, right? And supply oxygen to the reaction. But the problem occurs when you charge the system, because OER it may occur inside and produce oxygen bubble. And that oxygen bubble will break your electrode, okay? So what do we need? We need this structure, which is more stable. We call it self-supported electrode, okay? It's porous, okay? And the catalyst attached to the substrate, conductive substrate, directly, okay? So for OR, it's totally fine. But for OER, well, you have to be sure that all the generated oxygen bubble can leave the surface without destroying the structure, okay? So we solve the problem, all these problems, by using tri-electrode structure. Yeah, there is a text written here as a tri-electrode configuration of zinc air battery, where we use three electrodes: a common zinc electrode, OER electrode for charging, and OR electrode. So for charging, we use common zinc electrode with OER electrode, okay? And electrolyte flow through this small channel here, And during charging, of course, zinc will deposit at the innermost, and at the middle layer, OER occur, and OER produce small oxygen bubble, and those, yeah. Oh, yeah. Yes, it's okay. Yeah, I can. Okay, so we have to shut down the system, but it's okay. I will keep talking. All right, so we still have a slide, then it's okay. The oxygen bubble generated will not leave the system this way. Will leave the system with flowing electrolyte, okay? And during the charging, we consume oxygen this way. Oxygen bubble will go this way. And we connect the OI electrode with common zinc electrode there, okay? So this is the performance during charging and discharging. You see the difference. And it's quite stable. And with this structure, we can guarantee, well, at least 50 milliamp per square centimeter and the capacity of 150 milliamp hour per square centimeter. And it's stable, more than 2,000 cycles. And you see that we have charging profile and discharging profile. The main, the weak point or disadvantage of zinc air battery is OR and OER. So we deal with OER. Well, and I told you earlier that the over potential is quite high. So you see, charging voltage is about 2 volts, okay? With better structure and better OER catalyst, we can further reduce the charging voltage, okay? Anything close to 1.8 volt is good. And for the charging electrode, we use OR catalyst, okay? And the charging voltage of 1.2 volts is good, okay? So, yeah. So you see, now the efficiency, voltage efficiency is about 70%, 60%. What we're going to do if we want to increase the efficiency? To increase the efficiency, you need better OER electrode, so you can push down the charging voltage lower. Also, for the charging voltage, you have to increase the discharging voltage by using better OR catalyst and also better configuration. Okay? You can have question this time, during this time. While we are setting the projector. If you want, you can ask question first. I will entertain it. That sharing block. Should I? Pardon? Okay. Okay. Okay, good. Thank you. Yeah, we can continue. You see, this is what I mentioned about charging voltage and discharging voltage. With better configuration and OER, you can press down. You can push this charging voltage down, but never less than 1.6, okay? Because 1.6 is equilibrium. And better OR electrode and configuration, you can improve the charging performance, okay? To better than this, yeah? But never better than 1.6, okay? There's a case that you have lower charging voltage than 1.6. In some case, well, you use photo assisted. That means you shine light, yes, and your catalyst work. It's a photo catalyst also. Yeah, you can further push down. Okay, and in that case, you can improve performance. So, we are talking about OR and OER electrode. The next question is, how can we design and synthesize that OR and OER electrode? There's many ways, but what I'm going to introduce to you is by using MOF structure, okay? Yeah, this is another application of MOF, which just won the Nobel Prize this year, right? So with MOF, of course, we can avoid using non-noble metal, okay? And we can design a low cost, I mean in terms of cost of the element itself, we can avoid using the PGM, okay, platinum group metal. And if you want, you can design bifunctional OR electrode catalyst. And because of porosity of the MOF, we can design efficient and durable also, okay? So this is the work we use iron nickel MOF. We start from iron nickel MOF and we introduce the cation deficiency. The technique we use to synthesize it, we start from MOF. We design the MOF first, and then we use alkali etching to remove some metal atom out of the structure of the MOF, and then we polarize it. Okay? And then we obtain carbon nitride, graphitic carbon nitride, and decorated with iron and nickel. Okay? In this case, it's iron nickel oxide. Okay. So, well, we test that in our battery, both in flow cell and also in flexible battery cell. Yes. Okay. That is story about zinc air battery. Okay. You see that with very abundant material, active material like zinc and oxygen, we can do something with make it as a energy storage system. And the next one is zinc ion battery. Okay, I will touch zinc ion battery only little. For zinc ion battery, at the anode side, we are playing with the deposit, dissolution and deposition of zinc, like what we use in case of zinc air battery. But in this case, the electrolyte is not alkali anymore. Normally we use neutral electrolyte or mildly acidic electrolyte. What about at the cathode, which is a host material? The fundamental is similar to what we use in lithium-ion battery. We call it intercalation host material. So we rely on intercalation, Okay? So in case of lithium-ion battery, you use cobalt-based or even, well, polyanion like LFP, right? But for zinc-ion battery, you can use manganese oxide, vanadium oxide, okay? Or even, well, present blue analog. Okay. So for discharging, of course, zinc will oxidize, and at the cathode, zinc from the electrolyte will intercalate into host material. H is standing for host material. It can be manganese oxide or other vanadium oxide or other thing. And for charging, we de-intercalate zinc out of the host material, and we deposit zinc back to the electrode. So what is the problem for this one, for this system? We have hydrogen evolution reaction, similar to what we have in zinc air battery, because, well, this is aqueous electrolyte, but it's not alkaline. It's neutral or mildly acidic. And we still have problem of dendrite formation. Okay? To avoid this, we have to guarantee that zinc we deposit at the same place, in the same phase, all the time. And corrosion of zinc, because zinc can donate electron directly to water. So activity of water is really important. It contributes to all these issues, okay? And we have problem of passivation also, but in this time it's not zinc oxide anymore. We call it zinc hydroxide sulfate, because we have sulfate ion inside the system. And to solve those issues, we can use gel polymer electrolyte, okay? We use gel polymer electrolyte. This one, we use PAM. Okay, polyacrylamide hydrogel. So the idea is to limit the activity of water inside the electrolyte. Okay? Or if you want to use a liquid electrolyte, we work on the artificial solid electrolyte interface. Okay? This one is made from COF. COF, it's a covalent organic framework. We have a surface of zinc, and all over the surface of zinc, we cover it with small layer of COF. The COF will allow only zinc ion to pass through this layer, but blocking the water, so we can reduce the water activity. Okay. Or we can totally replace the aqueous electrolyte with other electrolyte like organic electrolytes, okay, similar to what we use in lithium-ion battery or sodium-ion battery, or use room temperature ionic liquid, okay, or deep eutectic solvent, okay. And the one we developed in our laboratory is dimethyl sulfoxide. We use dimethyl sulfoxide as the base of the electrolyte. DMSO is a polar protic solvent. That means it's free proton, okay? Proton free, no proton. So you can avoid reduction of hydrogen. You can avoid totally HER in the system. And by using DMSO, we can control the morphology of deposit zinc, okay? In case of aqueous electrolyte, it tends to form small grain, and it's easily detached, can easily detach from the electrode, and we call dead zinc. But in case of DMSO, well, it's formed a large ball and not easily to detach from the electrode. And we can stabilize the system by using DMSO. And in order to improve the performance, we study the effect of water in DMSO electrolyte for zinc-ion battery. And we found that by introducing small amount of water to the electrolyte, in this case it's 5%. 5% I call small. You may not call small, but I call it small. Yeah. We can largely improve the specific capacity of zinc-ion battery while still stabilizing the zinc-ion battery system, because that water changed the pathway or the mechanism of the intercalation of zinc. We use AGS to confirm stability, and also XRD to confirm the mechanism, and also with XRD. And we found that in case of dry DMSO, the interlayer spacing is about 7 angstrom. But in case of wet DMSO containing water, we found that the interlayer spacing changed from 7 angstrom to 10 angstrom because of the pre-intercalation of water molecule into the layer manganese oxide. And it increased the spacing here and allow easier intercalation of zinc ion. And by that idea, we found that, well, water molecule or small molecule can pre-intercalate into layer manganese oxide. So we designed the new cathode material by replacing the molecule. We pre-intercalate the manganese oxide, layer manganese oxide with ammonium instead. Okay? We start from pristine manganese oxide, layer manganese oxide, and then we wash it with ammonium thiosulfate, and we found that ammonia from ammonium thiosulfate pre-intercalate into manganese oxide layer. We confirm it using FTIR because, well, this is layer structure and also this is layer structure. And it doesn't change much, so XRD cannot confirm it, but FTIR can confirm it. Okay? And we found that by pre-intercalate of the ammonia into manganese oxide layer, it creates hydrogen bond network. Okay? And this hydrogen bond network can facilitate the intercalation of zinc, and at the same time, it can reduce the effect of Jahn-Teller distortion. Okay? When manganese in manganese oxide change from 4 plus to 3 plus. Okay? But this one allows the, well, reduce the effect of Jahn-Teller. Yeah. And this is the rate capacity of the battery compared between ammonium manganese oxide cathode, and this is pristine manganese oxide. Okay? It's still stable, and we can improve the capacity. Okay? We further work on the, well, study on the interfacial dynamics of zinc ion batteries. We want to know, in this case, we want to know how deep that zinc can intercalate into manganese oxide layer, and with the help of our friend in Soleil, we developed a technique called GI, Grazing Incident, AGS. Okay? By changing the incident X-ray, the incident angle, you can monitor different depth of the manganese oxide. Okay? By changing that, the incident beam must be lower than critical angle, and then we change the angle here, we can monitor different depth of layer of manganese oxide. And what we found is, well, we found that even in non-aqueous electrolyte, there is a change of manganese oxide during charging and discharging. During discharging, manganese oxide layer dissolve and reconstruct during charging. Okay? So at the interface still, we still have the change of or degrade of the manganese oxide layer. Okay, so let me conclude my talk. I introduce you zinc air hybrid flow batteries and also the critical components and the tri-electrode structure of zinc air battery, and, well, MOF derived OR, catalyst development, and the last one is zinc ion battery, which is kind of it's not flow battery, it's a kind of enclosed battery. Thank you very much. And if you have any question, I'm more than happy to entertain.
Thank you, Dr. Sodip Guyam. It was a very nice presentation, and I think it was enlightening lecture to most of the audience. So I request any questions from the audience or any clarifications, please.
Good morning, sir. Sir, very nice presentation to us. Yeah. So I have, I'm curious to know about, while we are using zinc, there is the possibility of corrosion and dendrite formation, right? And it is cycle life and thermal stability. So, do you have any protocol to controlling the limitations? And one more question, what will happen if you, instead of using the concentration of electrolyte, like salt gel formation electrolyte, what will happen? Electrolyte, if you change the electrolyte concentration, what will happen in the zinc on batteries? So, two questions I want to know about. Yeah.
So I want to confirm your question first. You asked about zinc air or zinc ion battery?
Yeah, zinc ion. Yes, zinc ion batteries.
Zinc air?
Zinc
Ion?
ion.
Yeah. That is really important. Thank you. That question is, it's a good question. For zinc ion battery, the main problem for zinc ion battery is this system is an enclosed battery. So if we don't follow the main reaction, if there is a parasitic reaction, it remains there, right? If we have corrosion, it produces hydrogen. Hydrogen gas will not leave the system, but remain there. And once it accumulates, it will explode, okay? So, and you see that if we use aqueous electrolyte, we can avoid by the idea to mitigate the corrosion. We have to reduce the activity of water. Yes. So if you really want to use aqueous electrolyte, the one way to limit the activity of water by this way, gel polymer electrolyte. Because gel polymer electrolyte, all the water are kept inside the polymer. So the active water will be less, much less. And the other thing is, if you don't want to use that polymer electrolyte, because polymer electrolyte usually has lower conductivity, ionic conductivity. You can use aqueous electrolyte, but fabricating the solid electrolyte interface. So imagine that you have active zinc surface and you cover it with something, and that layer has very high conductivity but allow only zinc ion to move through it, blocking all the water to direct contact to zinc surface. Yes. One way is this COF or even MOF. There are several people working on MOF or even hybrid system like mixing between metal oxide and polymer. Okay, that's a way to solve the problem, yes. Or in our case, besides using this aqueous electrolyte, you see the source is because the electrolyte contains free proton. If you replace electrolyte that containing free proton with new electrolyte without proton, you can totally solve the problem. For example, that organic electrolyte, you can use acetylnitride, or in our case, we use dimethyl sulfoxide, okay? Or you can use ionic liquid, room temperature ionic liquid. It doesn't contain water at all. Or deep eutectic solvent, it works. Yeah, thank you. And the other thing, did I respond to all your questions? The second question, what is the second question? Yeah.
Gel-like formation means instead of electrolyte concentration, what will happen?
Yeah, the performance will change. So normally you see that this kind of battery, once we discharge, zinc will dissolve into the electrolyte, right? And immediately zinc will integrate into host material, but not that zinc that will just release or dissolve, move this way. Yeah, it's a replacement, okay? So if you use very low concentration, the conductivity is an issue. And also, you see that the amount of available zinc in the electrolyte is lower, then the rate of replacement is lower. So the performance should be smaller, right? Thank you.
Nice presentation. I would like to know, how do you address the low voltage in zinc? Because in zinc batteries, generally we have low voltage. How do you address this? Sir, in zinc batteries, generally we have low voltage. How do you address this?
Okay.
Yes.
So the in-aqueous electrolyte, the zinc voltage, the electrode potential of zinc in neutral or acidic electrolyte is about 0.76. Yes. In that case, we cannot help. That means you need more cell to connect it and to boost the voltage. You can, if you want to increase the voltage a little bit, you can replace the electrolyte. If you use non-aqueous electrolyte, you can improve the voltage a little bit, but you don't expect that we can have voltage similar to lithium or sodium. That's impossible. Okay.
Yes, sir.
Yes.
So I'm having a doubt in zinc air battery graph, sir.
Zinc ion battery, what?
So I'm having a doubt in zinc air battery graph. Zinc air battery.
Zinc air battery graph.
Yes. So what's the question is, what parameter primarily influence the voltage gap between ORR and OER, and how do you design, so on which idea you design the catalyst, sir, to minimize it?
So let me show this photo first. These are cells in our laboratory. Okay, I skipped that last time. All right, so the first question, the voltage, right? Okay, so you can see from, let me show you the result of my tri-electrode structure. Tri-electrode zinc air battery again. You see that you cannot see here. The equilibrium is about this point, 1.6 or 1.65, around that. Okay, around here. That means you cannot cross it. Okay, you cannot cross it. What does it mean? You cannot charge at lower than 1.65. Even you use better OER, of course, maybe you can decrease a bit, but you cannot cross here. Okay? So if you want, of course, if I can say that it's very straightforward that you charge at lower current density, of course, the voltage will be down, right? And the other thing is, or you can flow the electrolyte faster. You also decrease the voltage, charging voltage also, okay? Because the effect of the concentration of the zinc cation inside the electrolyte. And for the charging, of course, if you use better OER, OR catalyst, you can move this profile up a little bit, maybe around here, okay? Or if you discharge at about 20 milliamp, of course you can discharge at 1.4, okay? But most of the time at 50 milliamp, yeah, you got this 1.2, okay? So, simple answer is you need better structure and better OR catalyst in order to improve this. And the other thing is, this one, we use alkali aqueous electrolyte. If you use for OER, for the OR, if you use acid, and for zinc, you use alkali, you can improve performance also. But I cannot guarantee the stability. Stability may be not good because, well, you have alkali and acidic. Alkali one side, the acidic one side. Well, in a long run, maybe it's mixed. Yeah, I don't know. Yeah, but for short term, of course, the performance, many people show that performance improve. Okay. Okay. Any more question on that? I forgot your question.
I have asked that on which idea you designed this catalyst, sir. So
Design the catalyst. Okay. So for catalyst, of course, normally we benchmark for OR. We benchmark with platinum or carbon. But you cannot have platinum and carbon in practical system because platinum is too expensive. So zinc atom or platinum, or you can design or based on MOF. The good thing about MOF is you can tune the structure, porosity, and also you can tune the metal ion. You can select which metal ion. Yeah. The problem about MOF is stability, but don't worry about that because we start from MOF and we pyrolyze it. So it's basically we preserve the structure of the MOF, but it changed to carbon. Yeah, carbon decorated with nitrogen and metal atom. Yes. And the other thing is, well, you can try perovskite oxide. Yeah, many people show that, well, perovskite oxide also show good performance. Okay? Yes, thank you.
Thank you, Doctor, for answering for the doubts of the audience. And definitely it was a very great session. So we understood why we have to choose zinc and what are all the challenges and how to overcome them in storing the energy from renewable sources. Thank you very much.
Thank you, sir, for the wonderful presentation. May I invite the chairperson of the session, Professor Dr. A. Rajan Samuel, Director Academics of Vinayaka Mission Research Foundation, to honor the keynote speaker of the session. I invite Professor Dr. V. Anbaragan, Principal of VMKV Arts and Science College, to honor the chairperson of the session. Thank you, sir. I invite Dr. S. Anandan, a scientist, F. International Advanced Research Center for Power Metallurgy and New Materials, ARCI, Hyderabad. I invite the chairperson of the session, Professor Dr. K. Ramesh, Director, Alumni Relations and Placements from Vinayaka Missions Research Foundation, deemed to be university. The session is yours, sir.
Good morning to you all. We'll start the second keynote speaker for the day, Dr. Srinivasan Ananthan. He's a senior scientist at the Center for Nanomaterials, International Advanced Research Center for Powder Metallurgy and New Materials, Hyderabad, for the past 12 years. His research currently focuses on production of lithium-ion battery material technology for electric vehicle application, design, fabrication and demonstration of indigenous supercapacitor device and development of self-cleansing technology. His research outcome has played significant role in Indian energy and environmental scenario with focus on lithium-ion batteries, supercapacitors, photocatalysis and porous nanostructured materials. He has been instrumental in developing indigenous technologies for the production of battery-grade LFP cathode and LTO anode materials, marking a paradigm shift in India's technological landscape. Through rigorous research and development, he has successfully demonstrated the viability of these cutting-edge technologies, guiding them from preparation to prototype. Apart from technology development, he is also a well-known, well-balanced in fundamental R&D for the fulfillment of successful completion of various DST-sponsored and industrial projects with targeted goals and achievements. Dr. Anandan has taken a special interest in establishing the state-of-art facilities, including semi-pilot plant facility for the fabrication of supercapacitor, dry room for lithium-ion supercapacitor device fabrication, high-energy milling unit, industrial large-scale furnaces, and electrochemical characterization lab for the validation of indigenously developed materials at prototype level. He has various publications including 73 papers in 18 international and 7 national patents, 3 book chapters, and he has a H index of 34 and I-10 index of 50 with an average impact factor of 4.74 with total citation of 4,886. He is a recipient of the prestigious JSPS Fellowship by Japan Society for Promotion of Science Japan. He received the prestigious Young Scientific Award 2008 by Material Research Society of Japan in 2008. Very recently, he received the ECSI Amara Raja National Award 2024 for his outstanding contributions in the field of electrochemical energy conversion and storage technologies. He has many laurels to describe, but due to short of time, I invite Professor Dr. Srinivasan Anandan to take over the session. Welcome, sir.
So thank you, Chairman, for your kind introduction. They are working. Before that, I will give that brief background about my title. First of all, let me thank Professor Anbalagan for inviting me to deliver a lecture on this international conference on energy, environmental and healthcare. So very glad to be part of this conference, and I hope you have that wonderful 2 days lecture for all the students and all. So the background of my presentation is, I would like to briefly summarize that. Right now we have been using lithium-ion battery starting from that all the electronics, and then two-wheelers, laptop, wherever it is possible we have been using lithium-ion battery. There is a huge requirement in India. So for example, our population is nearly 1.42 billion people we are, and then nearly 1.2 billion mobile users in India. So considering that requirement, there is a huge requirement. Unfortunately, there is no company in India making that lithium-ion batteries, even though there is a huge demand. So in the context of current requirement, it is high time. We would like to have our own indigenous lithium-ion battery technology to make India's self-reliance in this particular lithium-ion battery technology. And So my presentation covers how ARCI we have contributed for the development of lithium-ion battery technology in India. So the title of my talk is Innovation in Energy Storage, how we have developed that lithium-ion battery material developmental activities which are being used in that energy storage devices. This is the outline of my presentation. So I'll be presenting that material developmental activity for both lithium-ion battery and then supercapacitors. And then if time permits, I will present that super battery also, followed by conclusion. I think this slide is very familiar to all of the audience. Currently, whatever that energy requirement we are made by that fossil fuels. For example, that oil, natural gas, coal, and the nuclear power we have been using to meet our energy requirement. But the problem in this fossil fuel is the sources is available only for limited time. And then moreover, when you are burning this fossil fuel, lot of CO2 it emits into the environment. So the other major issue here is we have been continuously using this oil for this transportation, and then as you know that currently oil price keep on increasing, and then nearly transportation sector alone it consume 1/3 of oil which we are importing from that Gulf countries. So there is two issues. One is we have that limited fossil fuels, and then more of CO2 emission it is happening in the environment, and then the other thing is transportation sector consuming more and more oil. So one way to address this issue is we have to generate the energy from renewable sources, and then we have to switch over from that our fuel based vehicle to the electric mobility. That is the two things. So right now we are trying to generate energy from that wind, solar, and then tidal and all, whatever the renewable sources we are trying to generate energy from that those resources. And then once you generate the energy, you should have the proper storage device. Lithium-ion battery and then supercapacitor both are promising energy storage devices. Two operates at a different working principle. For example, lithium-ion battery stores energy through electrochemical reaction, that is Faraday, whereas supercapacitor are store that energy only at the surface of the electrode, that is called that non-Faradic reaction. First, let me present that lithium-ion battery activities and all. So this slide it will be useful for that student who are that the beginner for that lithium-ion battery. Battery is a transducer which converts the chemical energy into the electrical energy. That's why it is called that battery. There are two batteries are available. One is primary and then another one is secondary battery. These are all the four different components of batteries: cathode, anode, electrolyte, and then separator. And then these are all the various cathode and then anode being used in that lithium-ion battery. So you may ask, there are several secondary battery in the market. What way that advantages of lithium-ion battery over the other secondary batteries? So you can see that lithium-ion battery, the energy storage capacity is 150 to 250 watt-hour per kg because it is having that high voltage. Moreover, it is having the cycle life compared to other secondary batteries, for example, nickel, cadmium, lead acid, alkaline, nickel metal hydride. So compared to lead acid, if you can see that lithium, because of that low atomic number, the weight is less. Within a given less weight, it stores more energy. That is the unique advantage of lithium-ion battery. These are all the three inventors. They have helped to commercialize that lithium-ion battery into the market. Professor Whittingham, Professor Yoshino, Professor Goodenough. All these three people, they have worked on different components of the lithium-ion battery. Finally, lithium-ion battery commercialized in 1990, and then they have awarded Nobel Prize in Chemistry in 2019. So the next two slides, I will tell you that what is the working principles of lithium-ion battery during charge and then discharge. These two slides are important. If you carefully look at, you will understand that entire presentation. Having said that, lithium-ion battery, it is having the cathode, it is having the anode. In between, you have that electrolyte and then separator. For example, you are charging your mobile phone. What is happening at the positive electrode, negative electrode? So see that there is a oxidation happening at the positive electrode. Because of that, whatever the lithium ion it is getting, It is moving from cathode to anode and it is intercalated into the anode. Whatever the electrons comes out of oxidation, it is going to the external circuit and then powering our devices, charging our devices. So if you closely see that two mechanism it is happening, two diffusion. One is that one is lithium, it is going from cathode to anode, electron. Electron, it is going from cathode to the external circuit. If you can control the transport of these two, lithium ion and then electron, you can end up that development of promising lithium ion battery. So two things are important. One is that you have to prepare that nano size cathode material. If you have that nano size particle, the diffusion path length is less and then your lithium ion diffusion kinetics it will be more. And the other one is you should have the good conductive medium. Usually we do that carbon coating on that cathode material so that electron transport property it will be improved. So these two strategy it is very important to increase the diffusional kinetics of ion and electron. What is happening during discharging? Exactly the reverse thing it is happening. So whatever that lithium ion which is intercalated, it is deintercalated and goes back to the cathode. The electron from that anode, it is powering our devices. This is the simple mechanism where lithium ion shuttling between the cathode and the anode. Sorry. So basically that lithium ion, it is shuttling between the cathode and the anode. The electrons which is generated from the oxidation and then reduction reaction, it is either charging our device or the powering our devices. So this is the simple mechanism where oxidation reduction it is happening. These are all the different application of lithium ion battery. So you may ask, what is electric vehicle? Electric vehicle is propelled by a motor which is powered by that rechargeable battery pack. So what are all the advantages of the electric vehicle? It is energy efficient, nearly 59 to 60% of electrical energy coming from the rechargeable battery pack it is used, whereas that fuel vehicle it can able to deliver only 17 to 21%. It is environmental friendly. When you are using the fuel vehicle, lot of CO2 green gas emission it happen. Whenever you are using electric vehicle, there is no green gas emission. And then moreover, so you can charge in your home itself. When you are talking about the advantage, there are challenges which needs to be addressed for the electric vehicle. One is that driving range. Driving range, whatever that the electric vehicle which is introduced in that Indian market, which can go about 300 to 400 kilometers. So if I am traveling from Trichy to Chennai, which is hardly about 300 kilometers, within single charge I can travel, there is no waiting time. Suppose if I want to travel from Trichy to my place Hyderabad or Chennai to Hyderabad, nearly 650 kilometers I have to travel. For charging that entire battery pack in the electric vehicle, nearly it will take 3 to 4 hours. So I can travel 300 kilometers. After that I have to wait for another 4 hours to get completely charged. Then I have to travel. No one wants to wait that many long time. So that is the one disadvantage, the driving range. But a lot of R&D it is going on. And then recharge time, as I mentioned, that nearly 4 hours it is taking. The battery cost. Battery cost is nearly half of the cost of that electric vehicle. If you are buying 8 lakhs, nearly 4 lakhs your battery cost it will go. Because we are importing that battery from that abroad. If you have our own battery, own technology, the cost we can significantly reduce that. And then safety. Safety, I think you must have seen several fire accidents in the electric vehicle. I will explain in the later slide why it is happening in that fire. So the another technology what it has come up for electric vehicle is battery swapping. So as I mentioned that, so if you don't want to wait for a long time till your battery gets charged, there is called battery swapping technology. Already charged battery it is available like fuel station, you are filling that fuel. If you go to battery station, there is a battery which is fully charged. So you can go and then remove your discharge battery and then put it your charged battery. That the technology called battery swapping. Already Indian government, they have introduced that swappable battery technology for e-truck. Recently it was done that. So in October 8th, the central government, they have introduced that battery swapping technology for e-truck. This slide gives you the clear reason why we want to go for that electric vehicle. For example, if you see that the cost of the fuel vehicle, it is 8 lakhs, and then in that the battery cost is nearly 3 lakhs. If you are calculating the running cost, when you are charging, it will cost about 50 rupees. With that, you can drive 100 kilometers. Suppose average person drive 10,000 kilometers per year. For driving 10,000 kilometers, considering this running cost, you need only 5,000 rupees per year for driving that electric vehicle. Whereas if you see that the fuel vehicle, even though cost is less, 5 lakhs, considering the mileage 10 kilometers per liter, and then petrol price of 110 per liter, for driving 10,000 kilometers, you have to spend nearly 1,10,000 rupees per year. So where that the running cost for your fuel vehicle, it is only 5,000 rupees. The running cost of electrical vehicle is 20 times lesser than that your fuel-based vehicle, and then there is no green gas emission. So moreover, government is giving that a lot of subsidy to promote that electric vehicle. So these are all that subsidy. I think who are buying that two-wheeler already, they have experience. So the government is giving 20,000 rupees subsidy for buying two-wheeler electric vehicle. In addition to that, they are giving that subsidy for industry also. The main advantage of introducing this electric vehicle is, so we can save up to $300 billion. That is equivalent to 20 lakh Indian rupees, which we are spending for importing oil from the Gulf country. And moreover, we can prevent that the emission of 1 gigaton of CO2, which we are emitting into the environment. These two major advantages when you are switching over in that electric mobility. So considering that advantage of the electric vehicle, so the electric vehicle introduced in different segments, four-wheeler, fully electric, hybrid, two-wheeler, and then buses. So a lot of electric vehicles running on the road, so considering the advantage. But the limitation is, whatever the technology which are established in India, it is all using that imported lithium-ion battery pack. That is the major disadvantage. And then recent news we are hearing from China to control export of high-end lithium-ion battery graphite anode material from November 8th. So if there is, because right now we are getting all that raw material, cell component, and then power electronics, everything from China. So now they have put up that announcement that they are going to stop. Don't we use our mobile phone? Don't we use electric vehicle? How to manage that? How to address this geopolitical issue? We should have our own technology. Then only, that is the only answer for this problem. That is where we understand that, and then we try to develop our own lithium-ion battery technology. So we know that we have to develop the technology for indigenous technology to make India self-reliant. So for what kind of component we have to work on that? This pie chart, it will give you the idea. This is that the various components involved in the battery. If you see that the cost component, 32 and then 11%. Nearly 43, now it range is extended to 50%. 50% of cost, it is coming from cathode and the anode. If you can develop that cost-effective process to make this cathode and the anode material, you can substantially reduce the cost of the battery, which will reflect in that final cost of that electric vehicle. That is the reason ARCA, we are working on development of low-cost, simple, and then scalable process for the synthesis of cathode and the anode material. This is the fire accident, I think you must have seen in that newspaper. So it is happening in that mostly two-wheeler in India. Even US also, Tesla car catches fire in 2023. So why it is catching fire? The process is called thermal runaway. As you know that India is tropical condition, so the summer, the temperature, it may go 45 degrees centigrade and all. So accordingly, you have to choose the right chemistry, which is having that high thermal stability and all. So whatever we have used in the two-wheeler, it is the layered oxide material, NMC, which is having thermal stability only up to 30 degrees centigrade. When the surrounding temperature increases, For example, when you are riding during summer, the temperature increases. So there are various components. As I mentioned that the SEA layer on the anode and then electrolyte separator, all because of the temperature increase in the battery, it is getting damaged. Moreover, whatever the oxygen from the cathode structure also, it is coming out. When the oxygen removed from the crystal structure, it is the fuel to the fire. So there are lot of exothermic reaction it is happening within the battery. Because of that, the heat which is built up in the battery, finally it is explode. There is a lot of reason for that. One is climatic condition. When you are overcharging also, there is a temperature increase, cathode chemistry, and then quality of the battery. Quality of the battery means sometimes we are getting second-hand quality battery from China. We don't know what kind of battery we are getting and all, because we are not checking the quality control and all. In that case, when you are using this kind of fire accident, it happens. So it is essential to develop cathode material which withstand Indian tropical condition. These are all the various parameters you have to consider to develop that cathode material. Among these, the energy density should be more than 250 watt-hour per kg, and then your voltage of cathode should be high, and then for Indian market it is cost sensitive market, and then should be low cost, and then it has to come for long cycle life. These are all that main parameter you have to consider before you design that cathode material. So these are all the two cathode material being used in that lithium ion battery. These two cathode chemistry, which chemistry we have to select. So based on this table, you will identify that which cathode is suitable for our Indian condition. For example, one is LFP cathode, another one is NMC cathode material. If you see the voltage, your layered oxide material, it is having the high voltage. Because of that high voltage, it is having the high energy density. Whereas if you see the LFP, it is having only 3.2 volt. Because of that, it is having the less energy storage capacity. But if you see the other property like thermal runaway, chemical stability, cycle life, it is having superior property compared to that NMC. So no one want to compromise that the safety for having that long range battery and all. So that is important. Moreover, the cost per kilowatt hour for LFP is lesser than that cost of NMC, because lithium, nickel, cobalt, all are critical mineral which we are getting from that South American country and then African country. So whatever this low voltage, low energy storage capacity also recently addressed by that cell to pack technology. Conventionally we are using cell into module, module into pack. This way we are assembling into the battery pack. What they have done, directly they have fabricated the longer cell and then converted into the pack. By doing this, they have increased that efficiency nearly 40%, which is similar to that NMC cathode material and all. So considering this advantage, high thermal stability, and then that reasonable good energy density, we have chosen this lithium iron phosphate as a cathode material for our study, because it is having that strong covalent bond between phosphorus and oxygen. So the oxygen will not easily come out of that crystal structure. That is where it is important. And then the two issues are there in that lithium iron phosphate. One is it is having that low electronic conductivity, another one is it is having the low ionic conductivity. So if you want to address that low ionic conductivity, you have to prepare the nano size cathode material. If you have to do that on top of that material. So cell strategy, you have to stand model, so the EM infusion and carbon, you have to do that on the electron and put body in this. So it's all different. That you need to be looking at no is one file is with when you do the solid recycler process and you get an effective. The RIAC portion of the release possible that with portion of the power. Then you also have a panel being unit. There's also involved that. Why you have to take a powder cursor and randomly, so it will get internal particle. Here the brain 2.8 per hour. This is the way we have been captured and application at box level. Finally, you have waiting at the table. So what you have done is from keys level. Initially, you have used the pass. In first process, we used the FP by the FP, flip the and got the answer part. In the sketch, we have a transfer. So we got the core structure, transfer the FP and then we have evaluated electrical performance. Here you can see the fund of RLP is 1.1 in ampere per program, which after the performance of imported LPT and better than the transmission made. So here we adopt two-step process. We are repeating these processes and we do the transfer. So when for actual this kind of process is not So we try to develop that silk process where we to make the NO parallel count in silk process. What we have done is we have taken the carbon phosphorus precursor and then we have done the high energy blending. We are doing the high energy blending. Kinetic energy will the kinetic energy transferred to material to next setting. And also we made a uniform mixing into the element and once the will be a calculation. This is where we are in the material of hardcore like PO. Here the access we optimize energy batch. And then you are not share. This is pass here is still a pass. We have the energy carbon and the pass easily scalable at the last time that one would take. This is the acceptable form of material. So now you sense block material. You see how I correct they were power and different grade. Here how material is able to deliver what they made in power. So when you doing the coaching, it's able to deliver 1.5 hour. When you are passing 5 you give 1 minute. Even for how it able to deliver 110 hour. So always start is to we to base up only with the particular material. This is the how much AS material. See it in zero charging. 10 much charging. 1 minute, 1 charge, 1 minute charging, 5 minutes, 1 minute charging, 1 minute charging. So you see the form gas level is dealing with India which shows that the material here. Here we do the fast charging. Our AS material able to deliver 1 time ampere which is a commercial material. It's mean because we deal with the particle and then we take it from parting. We have not stopped only a last year. We try to change our the process we have last year we only here. We try to see it for 50 kg. So this is all the initial level in the city. First city you then we done a lot of optimization. You all are in one entity. We are all in city. Now we have made our own facility for change the process which we have up here. This is process involved. Then nearly 1 km we use very this order we do the casting structure. This is where we have done 3 kg back. We are making for what we are up here. So finally this material we have evaluated in service. So finally, develop here we have finally to area the aircraft. Therefore, the only number and technology. Here, the final one is the limb checking you did mobile phone or laptop or so we have it's using our engineer CAP as well as it's using machine learning. And we have developed the recommended for large capacity. Whatever the we are high level is different level also. Even at past grade, our cell made for CAP and 9 to us rate. Where they made for the quality, they only have capacity. It is having a long cycle. So this may have to the answer that part of the we have in pitch different separate fish all we have. Finally, technology called that phenomenal regulated and we even on price in the other company they come forward that Altman Private Limited. We have given that the global exclusive right other than India. Within India we have given non-exclusive rights. And then this company they come forward to incubate our technology within our campus. So they have set up this incubator with a production capacity of 50 kg per day. Now they are making 100 kg per day. And then this was done at 2023. So this is the roadmap how we have started. So it all started at the lab scale to 70 gram and then we have reached 50 kg per day with the incubator, the semi-pilot plant. Now that, so other important thing of our important unique advantage of our technology is except lithium remaining raw material available in India and then the equipment which are used for milling and then furnace, everything you can fabricate within India. So this is the, with the most of available indigenous raw material, we could be able to develop this technology. So the company now they are going to set up that 1 ton per day. And then recently they have put that foundation for establishing the commercial plant with the production capacity of 10,000 metric ton per year. Soon we will be seeing that the commercial production of material which is coming out of our indigenous technology. So once it is ready, they will be supplying the material to the company and then they will be making battery out of that. That's where our success story for developing the technology and transferring the technology to the industry and then now they have been working on the commercialization. Sir, how long I can? Another 10 minutes, please give me, sir. So whatever I talked about is, it is lithium-ion batteries. So here we rely lithium raw material from the South American country like Argentina, Bolivia, Brazil and all. And then if you want to develop any non-lithium based energy storage, supercapacitor is one of the energy storage. And then we found that the lithium source in Jammu, Kashmir and all, but it takes some time to explore suitable mining technology to purify lithium and all. Here the alternative to lithium-ion battery is supercapacitor. Supercapacitor, it is having the similar structure. It is having the cathode. It is having the cathode, it is having the anode. Here both cathode and then anode is carbon based electrode. And then you have that electrolyte, positive and the negative electrolyte ions. So here what it happens, during that charging, whatever that oppositely charged ion, it gets absorbed on that electrode surface. So this is what it is happening during charge and discharge. Here there is no chemical reaction. That is the reason it cannot store more energy. So the limitation is nearly 10 times lesser energy it can store. But the advantage here is it is having long cycle life, and then instantly it can able to deliver high current, and then more importantly you can do the fast charging and then discharging, because the storage it happen only at the surface. Considering that fast charging advantage, already China they have introduced supercapacitor powered bus for public transportation. Every 10 kilometers they have put up the charging station, and then bus goes from one bus stop to another bus stop, it will discharge here, it will be charged again by the time passenger get in, get out, and then after charging it drive for another 10 kilometers. Like that they have so smartly introduced this supercapacitor powered bus for public transportation. This is the mechanism, already I explained. So what we are trying to do here is in ARCI, we try to develop the porous carbon from either bio waste or industrial waste, which is alternative to the coconut shell derived carbon which is available in the commercial market. And then from this carbon we want to fabricate the supercapacitor. Finally we want to demonstrate for EV application. This is that the jute stick, I think everyone know that. Jute plant is there after extraction of jute fiber, jute stick. This jute stick we have used as a raw material. After chemical activation, we could able to synthesize the graphene-like structured carbon material. And then this all the crystallinity, everything it is confirmed by Raman. In addition to D and G band, we also get that 2D band at 2700 centimeter inverse, which is having that high electronic conductivity. And then this material, we check that the charge discharge profile. And then we compared with the performance of commercial material. We got that performance of about 132 farad per gram for that jute stick derived carbon, whereas commercial carbon it delivered only 91 farad per gram. Our material having superior performance, but the problem here is it is only we are getting the 35% yield. If you are taking 1 kg jute stick, you will be getting only 350 gram. That is commercially not attractive. What we have done, so we try to use the pet coke, which is one of the byproduct during the oil refining process. We want to convert and try to give some kind of value addition for the waste which is generated in large quantity. Similar chemical activation process we used and then converted into porous carbon. This carbon material, it is having the bimodal distribution and then having that 2D band in addition to D and G band, and then graphene-like structure carbon. This material shows superior performance, that is 128 farad per gram compared to the commercial 98 farad per gram. Here the advantage is we got the yield of 60 to 70%, which is double the time of bio-waste derived carbon. With this carbon, we made that supercapacitor. So first we made that electrode, and then along with the separator we made the jelly roll. Finally we made that supercapacitor using our own the pet coke derived carbon, and compare the performance of our supercapacitor with the commercial Maxwell supercapacitor device. And then these are all that different properties of ARCI compared with the Maxwell commercially available supercapacitor. If you see the performance, our performance of ARCI supercapacitor is 1198 versus 1165, and then energy storage capacity also it is high. Overall, we successfully fabricated supercapacitor using our indigenous carbon material. And then finally this supercapacitor we have assembled into a model and then put it into the bicycle, and then bicycle we ran for 1 kilometer. The entire model, it takes only 3.5 minutes for charge. That is the advantage. So the material we have fabricated, and then supercapacitor we have that made out of that carbon, and then finally we have demonstrated this one. These are all the different other applications we have been working on for supercapacitor for power drill and all. And so you know, one is lithium ion battery, it can store more energy because the electrochemical redox reaction it is happening. Supercapacitor, it cannot store more energy, but it can able to deliver high power. We want to prepare a single device which is having that both property of lithium ion battery and then supercapacitor. So we made that, sorry. Only 5 minutes, sir. 2 minutes, sir. 2 minutes. I'm going to put it conclusion. Yes, please put it into that. So we have prepared that single device which is having the property of both the lithium-ion battery and then supercapacitor. This is called super battery because even at 17C, which takes only 3.5 minutes for charging, it is able to deliver more than 90% capacity retention and all. This battery we are trying to use for drone and then forklift, wherever you need that high power, this can be used and all. So already we have been working with that Magic Mina, the company working on that drones and all. So this is the conclusion. We have developed that lithium-ion battery indigenous cathode material for lithium-ion batteries, and also we have developed that supercapacitor which is having that fast charging capacity, and then the material which we developed from that industry waste derived carbon, we fabricated supercapacitor and then demonstrated for EV application. I thank all our management and my colleague and then my staff working on different projects to execute this project. So this slide is very useful for that student. In ARCA, we have been giving many opportunities for that student who are doing final year BTech or MTech or MSc. They can come to ARCA and then they can do their project starting from 3 months to 1 year. Who are completed the graduate or master graduate, they can also apply. They can work for 1 year at ARCA. And then we used to give that advertisement for JRF, SRF. So throughout the year you can see, and then you can, if you are interested, you can apply. And then we used to give the advertisement for project scientists. Recently we have given advertisement for that the project scientist 1 and 2, but already that due date it is over. So, but you can regularly check our website and then try to apply that whenever you have that eligibility and all. Thank you all for your kind attention. Finally, I thank Professor Anbalagan and then other organizing committee members for giving me this opportunity to thank you. Thank you all.
Thank you, Dr. Anandan. It was an excellent presentation on lithium-ion batteries, the going green and giving all the challenges what we are facing. And it also gives us an eye-opener for the youngsters how to develop the new perspectives on lithium-ion batteries and other supercapacitors which you have mentioned. The scientific session is open for discussion. Any questions? I can take few questions, 1 or 2 questions. Any relevant questions? Okay, please go ahead.
Hello, ma'am.
You have mentioned that lithium-ion battery. Same work we have done in our laboratory, in our research team we have done, lithium iron phosphate. The fabrication method is solder method. In your slide, you have mentioned that multi-element NMC. Yeah, and that comparative tables.
This table you want to know?
Yeah, yes sir. Lithium, nickel, manganese, cobalt and oxygen. Is it high entropy alloys, sir? High entropy oxygen?
No. It is kind of layered oxide. Where you have that nickel, manganese, cobalt. Initially we are preparing the white oxide. And then they are mixing with the lithium carbonate when we are doing the fabrication. It is not high entropy.
Do you have any idea? Do you have any idea to compare your lithium-ion battery with the high entropy elements?
So recently it is coming up all the time.
Yes, sir. It's not.
The conditioning is effective for the
Yeah.
So you have got to take cost effective, then you are so you have got to control all the proper starting from the voltage capacity, outside the thermal stability. Those aspects you are high entropy alloy feature, then you are in the
Foreign countries are doing, sir, but not yet received, not yet implemented high entropy alloys here. In India, we are not receiving any.
One more question.
Dr. Anand gave a very good, useful talk. And I am a Baniya, so I would like to ask two questions. If you go for electric car, you told us it costs about 5,000 rupees for running 10,000 kilometers.
Yes, sir.
And for other cars, it takes 1,10,000 rupees. So do you mean to say that everyone should use electric car?
Definitely, sir. Considering that the global warming and all, considering that advantage, this is one of the cost effective and then other one is low green gas emission. So, but as you mentioned, there are some risks, sir. This means you have to choose the right chemistry for Indian conditions.
But the right chemistry says that these lithium, lead, they cause pollution, so you are just polluting the environment.
That is a very good observation. So right now to alternate that we are using renewable sources. So directly you are getting that energy from that all that solar energy. From that when you are doing that, trying to store those energy and then trying to charge from that solar energy. So you are not emitting anything. So whatever you said is correct. When you are using grid, again indirectly you are responsible for that whatever the CO2 emission. But when you are trying to use that renewable sources, then there is no emission.
Let us see. It works. Thank you.
Yeah, last question.
Sir, we all know that we are going for net zero by 2050. Okay, so we have there is no choice. We have to go for EV vehicles, everything. Already we are generating about 62 million tons of solid waste, and in that 15 to 20% is our e-waste. So is ARCA is going to give any, it's just for understanding, sir, solution for the waste management after doing everything, going for emission, then reducing pollution? Is there any technology, because now we are very much advanced, is that any technology being proposed side by side while we are going for EV conversion from non-renewable sources?
Very good question, madam. So that lot of e-waste we are generating. How to do that? That morning myself, Kalivani madam, we discussed that. Recycling is very important. Once you recycle means we want to recycle the critical minerals. For example, lithium, cobalt, nickel, which is not available within India. Those kind of things we can regenerate. What ARC we are doing means we are not into that lithium-ion battery recycling, but we are extending support to the company who are doing recycling. For example, Logam, Attiro, they have set up that 2-ton capacity recycling plant. So they want to validate their recycled material, because already we have the established process for making cathode and anode material. Instead of using commercial lithium, we are trying to use the recycled lithium and then see that how the performance. What we observed is all the recycling companies, they have reached the purity of 98%. But for battery grade, we need that 99.999. So there they are struggling that. So where we are giving that technical input, maximum all the inorganic minerals are there in that 1.9%. Sodium, magnesium, calcium, those are all whatever we are using for recycling. Those minerals are there. There we are giving our technical advice to do some kind of acid leaching to remove those minerals and then try to improve that the purity of that the recycled lithium and all. That's where we are extending support. So the important thing is, if we can able to recycle whatever that after the end of usage of lithium-ion battery, the lithium from that recycled battery itself, it is sufficient for us. Again, you don't need to rely on that the foreign countries, South American countries and all. So if we have that efficient process, there are hydrometallurgical, pyrometallurgical, those processes and all they have been using. I think hydrometallurgical process is most economical process. Now there are many companies, different companies they have been working on that recycling of lithium-ion batteries and all. Already government side they have initiated, madam, National Critical Mineral Mission. There is one, the government, the coal ministry, they have put up this National Critical Mineral Mission. They have been actively working on that, and then recently they have created National Critical Mission Plan. In that, recycling is that the major part in that. And then they are encouraging all that, giving subsidy to the industry, and then trying to involve more company for that recycling. That it is going on.
Thank you so much. Thank you, sir.
The last question. So sorry for time delay.
Yeah. Thank you so much, sir. Dr. Anandan, you are it's a highly debatable topic. We can go on and on and on. So as there is a lack of time, I would like to wind up this session, and I thank Dr. Anandan for giving this excellent overview about the various proposition of using the lithium ion and other alternatives. Thank you, sir. Thank you very much, and we are privileged to have you today.
Thank you, sir, for your wonderful presentation. May I invite the chairperson to honor the keynote speaker of this session. May I invite Dr. M. Nithya, Vice Principal of Vinayaka Mission's Kirupananda Variyar Engineering College, to honor the chairperson of the session. Thank you, sir, and thank you, ma'am. Dear attendees, a tea has been served outside of the auditorium. A tea break for 10 minutes. There will be a parallel session, and first session is going to be held in this auditorium, and the second session in seminar hall.
Okay. Thank you, ma'am. Hello, sir.
finalist traveled extensively, interacted with experts, and participated in various academic programs in South Korea, Japan, Poland,
United States of America, Singapore, China, Sri Lanka, and delivered more than 50 invited talks. He is an recipient of Brain Korea 21 postdoctoral fellowship during the year of 2017 to 2008. Then he received a young scientist research grant from 20 lakhs from the agency of DST, India in the year of 2010. He won many best paper awards. He has been awarded Tamil Nadu Young Scientist Award for the year of 2016 in the discipline of Physical Sciences. Recently, he received a Distinguished Alumnus Award from Jamal Muhammad College, Trichurapalli. With this, I invite our resource person, Dr. Manivannan, to proceed his presentation. Thank you, sir.
Thank you very much, madam. Am I clear at the last? Yeah. Very good afternoon to one and all gathered here. It's my pleasure and privilege to be here to share some of my research experience in the presentation titled as Nanocarbon Molecules for New Generation Devices. Before getting into the business, I would like to thank the organizers of VMKV, especially the principal who offered the invitation to make an invited talk in this international conference focused more on energy, environment, and healthcare related topics. You can reach me out by writing to my contact or for short discussion. You can also communicate via the voice. Coming to the outline, let me start for the benefit of a few youngsters with the low dimensional materials, followed by nanocarbon molecules and their properties with a special focus on carbon dots, followed by carbon nanotubes, graphene derivatives, especially on graphene oxide, reduced graphene oxide. And then we'll share ideas or the opportunities in making new generation devices purely based on the carbon-based materials. Well, this is the picture of the Great Wall of China, the top view of Great Wall of China. The quite interesting thing here is the breadth of the Great Wall of China and the height of the Great Wall of China is almost equivalent, or roughly 4 to 5 meters when compared to the length of the Great Wall of China, which is in the order of 2,500 kilometers. So when you take the length, the breadth and the width is almost nothing. So we can treat this as the best example for the one-dimensional materials. If you replace the individuals, the visitors moving on the top surface of the Great Wall of China, where the confinement come to the picture. If you miniaturize the Great Wall of China, you will be ended up with the kind of the one-dimensional materials. If you chop the Great Wall of China into pieces of few meters, then that is going to be the zero-dimensional materials, or the best example for the confinement or three-dimensional confinement, which we call it as a quantum dots. So coming to the conventional way of understanding the low-dimensional structure when compared to the bulk materials, technically called quantum well, quantum wires, and quantum dot for 2D, 1D, and zero-dimensional materials respectively, where the quantum confinement played a prominent role in realizing the unusual properties of the conventional materials. Here, the quantum well, quantum wire and quantum dot all can be realized from a single element in the periodic table. So that is the beauty of the carbon material. That's why we are much interested on the carbon based materials, particularly on the low dimensional carbon or nanocarbon. Ideally speaking, it is possible with the all possible the solid material or the elements available in the periodic table. But the pretty interesting thing, we have a lot of limitation in the other materials, whereas the flexibility of carbon comes into the picture. So we are quite interested in working on only the carbon element rather than the other elements available in the periodic table. So this slide simply gives an idea how flexible this carbon is. So we might have heard this term flexibility. The carbon is very flexible, an organic element is very flexible. But look at this, the few structures like diamond, graphite, landolite, fullerene and amorphous carbon, carbon nanotubes, so particularly the single wall, double wall, multi-wall, and then the combination of the nanotubes and the fullerene and the computer models, which shows or demonstrate that the combination of the one-dimensional and zero-dimension and zero-dimension and so on. That means the carbon makes a lot of interesting allotropes, which makes the potential material for a variety of interesting applications for the future generation. Of course, the nanocarbon molecule, which is the title I have given here, is the dimensionality as mentioned, comes into the picture, or the restriction of the movement of the electrons, or simply called the quantum confinement, which makes a lot of differences in terms of properties, both the physical, chemical, apart from the mechanical and optical properties. And the nanotubes, fullerene, the graphene or the graphene based the derivatives, and the recent addition in the nanocarbon molecule is the nanobelt. Just a few years back, the chemist has successfully isolated the stable nanobelt in the laboratory, and the properties of the potential of nanobelt are still people are looking, and quite interesting material. Means only 27 or 28 atoms, carbon atoms, makes interesting functionality without compromising the stability at the room temperature. Well, so why we need to worry about this nanocarbon materials, or why we are looking the nanomaterials, particularly the carbon? Here is the top 10 world problems addressed by the Richard Smalley, who won the Nobel Prize in the year 1996 in chemistry for the successful identification or the isolation of the beautiful, the fullerene, the structure. The problem is the energy, water, food, environment, poverty, terrorism and war, disease, education, democracy and population, where the theme, energy, environment and the health, it's also listed here. So whatever the problem we encounter, it should be, or it may be, or it can be associated with any one of the top 10 world problems addressed by the Richard Smalley, or the combination of this. But the idea here being a physicist or a chemist or an experimental physicist or an experimental material scientist, we have also tried to find or try to address the global problems by playing with the materials without violating the physics and chemistry. So here the carbon can address the global problem without violating their physics or the chemical, the science or the properties of carbon can fulfill the requirements of the global the stuff by suitably tuning the materials. And to demonstrate or to reinforce the statement, here is the Nobel Prize in Chemistry in 2023 for their discovery and synthesis of quantum dots, particularly the semiconductor, the quantum dots. Means the demonstration of the unusual optical properties or the semiconducting properties at extremely small in size gives a lot of interesting the size dependent properties, tunable emission, high quantum yield for the semiconductor quantum dots. That played a prominent role making use of this wonderful zero dimension material in displays, sensing, imaging and the photovoltaics. So the carbon is also incorporated to replace the semiconductor quantum dots, but the problem here in this unusual material is the toxicity concern, the synthesis complexity, stability, limited wavelength range, and the high cost. If you are able to address any one of these the concerns or the combination, that is going to be a big the boost for this low dimensional materials. Here we have overcome some of the interesting so the difficulties in isolating or the synthesis of the carbon dots using the microwave, and this typical photograph shows the brown solid obtained at the end of the reaction which we have carried out using the microwave from the citric acid and the ethylene diamine, which is actually used as the source for the nitrogen and the source for the carbon, and finally ended up with the nitrogen doped the carbon dots which we have shined with the UV light. Shows quite interesting the luminescent properties. After synthesizing the nanoparticles, we tested the particle size using the HRTEM and also the crystallinity. Since we adapted the microwave, we ended up with the amorphous carbon, but the size makes quite interesting the luminescent property, which we have encashed it by developing the ratiometric fluorescent sensors for the hippuric acid sensing, because the hippuric acid can be treated as a biomarker of toluene exposures, which will give you an idea for an early detection of the challenging diseases like Parkinson's disease, liver cirrhosis, and the lung cancer, where the early detection is missing. So the hippuric acid, the detection will give you the early diagnosis of the deadly diseases. So we thought of sensing the hippuric acid by developing the sensors using the synthesized carbon nanotubes, the carbon dots. And here is the interesting, the quenching properties of the optical the luminescence by addition of the hippuric acid in the base material. And we also tested the selectivity of this the carbon dot based the sensors along with the other possible mixtures which is available in the bio waste. So which shows the carbon dots is a prominent material can be used for the sensing of the hippuric acid for the biomarking or the biomarker sensing development. In addition to the hippuric acid, we also use the green method to synthesize the carbon dots using the chromalena odor the extract, the leaf extract, which shows quite interesting properties in terms of structure, and also the deduction of Fe3 plus and vitamin C. So it started developing or working on this ratiometric based sensors, which improves the properties to avoid the signal to noise ratio or the lot of difficulties in improving the sensing limitations. So we successfully demonstrated this synthesized carbon dots can be used for the set the purposes like. So coming to the one-dimensional materials, mainly the carbon nanotubes, both the single wall and multi-wall carbon nanotubes. Here this slide demonstrates the variation of the usage of single to a mass nanotubes or a random to an aligned the nanotubes. We can combine the properties both in X and Y axis by realizing the conducting film application, making composites, gas sensors, fuel cells, batteries, mainly the energy storage devices, and the biotechnology applications, then the field emission backlight unit and cathode ray tube manufacturing, and then the biosensors, the electronic device manufacturing or the electronic nose replacement, and then the large scale integrated memory devices. The red in color is the focus of our interest in our laboratory. By keeping the theme should address the energy and environment, also the health related issues. And the one of the interesting application is the modern X-ray generators. The conventional Coolidge tube everybody knows, where it works based on the thermionic type emission, where the energy is in the order of the kilowatt or the you need to supply a huge amount of energy for the ejection of electrons to accelerate to reach the anode to produce the X-rays in the conventional Coolidge tube because of the thermionic type emission. Here our idea is to replace this thermionic type by growing the carbon nanotube on the metallic material. You can reduce the energy consumption where the cooling system is not needed. That means wherever you go the non-destructive testing method by using the X-rays, we need to visit the X-rays. It is not portable. And if you replace this thermionic type emission by the cold emission or the quantum emission using the carbon nanotubes grown on the metal substrate, and you can miniaturize the Coolidge tube, or you can use this modern Coolidge tube for the X-ray production by growing the multi-wall carbon nanotubes on the suitable metallic substrate. And this photograph shows that the schematic of the idea of creating the cathode at where we have grown the multi-wall carbon nanotube act as the electron source for replacing the conventional, the Coolidge tube. And this scanning electron microscope images shows about the grown carbon nanotube which has the sharp tip and capable of serving the purpose, the vertically aligned the nanotube to serve the electron ejection for the production of the X-rays if it is accelerated by hitting the anode, very similar to the Coolidge tube. So the images which we are getting, the non-destructive testing images which we are getting from the produced X-rays using the carbon nanotube emitter based the X-ray clearly indicates that the intensity of the X-rays is sufficient to take images very similar to the conventional X-rays, but the power and the size is relatively less. So our collaborators they keep working on this because it's a quite old problem. More than 10-12 years back we started working on this. Now we have succeeded in making the portable X-rays which can be used for non-destructive testing or the imaging purposes to replace the conventional X-ray stuff, right? And then coming to the single wall carbon nanotube, since it is a conducting material, a combination of metallic and semiconductors, the conducting properties can be tuned by purifying and dispersing it in a suitable medium, and we can replace the metallic material on the semiconducting materials to coat on the variety of the substrates to realize the transparent conducting films. Why flexible are the transparent conducting films? Because the future electronic device, it is not going to be based on the glass or the rigid substrate. It is going to be rollable, bendable and wearable devices where we need to find an alternate material for the metal oxides which we are conventionally using the indium doped tin oxide materials. To replace the ITO, we have quite interesting the one-dimensional carbon-based materials along with the other counterparts like polymer or conducting polymers. So to realize the flexible displays, wearable displays, e-paper and PCB boards. So the future display, it's all going to be kind of the flexible or the rollable or the bendable, and the pioneers was working on the flexible or the display industries. They already demonstrated few interesting things based on this nanomaterials, particularly on this the carbon based the nanomaterials. So we start working in developing the suitable electrodes by purifying the nanotubes and dispersing it in the suitable medium by realizing the conducting ink. So the ink can be transferred on the suitable substrate with the predetermined the temperature, and the spray paralysis or the spray coating is one such interesting method along with the spin coating to develop the thin films of the conducting material from the conducting ink. So the coated substrates will have the optically transparent but electrically conducting. That means you are capable of visualizing what is happening on the either side, very similar to your glass, but electrically conducting. So very thin or a very small amount of this, the black carbon stuff can be coated on the flexible the substrates like polyethylene terephthalate, polyethylene naphthalate, in addition to the glass. And this is the typical image showing the variation in the thickness depending upon the number of coatings, showing that the possibility of optically transparent but electrically conducting. For example, in this particular case, about 5 by 5 centimeter, the average sheet resistance is about 200 ohm per square for about 80% transparency at 550 nanometer, which is sufficient make LCD screen or the touch screen or the capacitive screen, which is playing a prominent role in all the electronic gadgets, including the mobile phones, because the cost of this the display is nearly 60% of the cost of your the electronic gadgets. So if we are able to replace the conventional indium doped tin oxide by the organic molecules like nanocarbon materials or the nanocarbon molecules, you can probably reduce the cost of the display. So that is the idea. In addition to the glass, we also tried to make a coat on the PES polyethylene sulfonate and the polyethylene naphthalate, the substrate, which also shows the quite interesting optical and the electrical property even after bending with 200 to 500 bending cycles. That means there is a prominent material lying on the low dimensional carbon which can replace the conventional the metal oxides for the touch screen and the flexible display applications like. So keeping this first demonstration in mind, in recent times we also moved to making the transparent the heaters and the transparent sensors to check the environment whether it is free from the hazardous the gases. So to keep this idea in mind, we also chosen the polymer and the cellulose paper as a flexible substrate, and we coated the carbon nanotubes and the carbon based material and the composites on the flexible substrate to make the sensor and the transparent devices. So here is the typical the process in the fabrication of the gas sensor on the paper. So the idea here is the normal Wattman paper where we coated the purified and the dispersed the carbon nanotubes after the purification process using the vacuum pump or the normal vacuum filter, and we control the thickness. Once the thickness is reached to obtain the required electrical and properties, and the portion is taken out after scissoring, and then we coated the electrodes on top of the film or the flexible film, and then we use this for the IV testing and tested the sheet resistance depending upon the deposition of the number of layers or the amount of the carbon nanotubes, and tested the suitability for the gas sensing by keeping this in the gas sensing environment by supplying the volatile organic compounds like ammonia, alcohol, acetone. Depending upon the concentration, the electron donating or the electron withdrawing nature of the gases, the physical attachment of the molecules on the surface of the carbon nanotubes coated on this flexible paper gives a variation in the electrical resistance. So mere IV studies or the change in the electrical resistance will give an idea about the presence or absence of the volatile organic compounds for quantification. So that would be helpful in many of the industrial applications, particularly for the fruit and the vegetable storage, where we are expecting the ammonia exposure or the ammonia concentration is quite important to control the ripening of the processes like. So in addition to the sensing, the sensors which we have developed is flexible and disposable. That means nothing to worry about it because it's made up of carbon and the cellulose of the paper. You can burn it and you can throw it. No idea to think on the recycle of all these stuff like. And another advantage is you can also wear it at the batch for the medical purposes, so that it can be used as a wearable sensors or the wearable the devices. Okay. So using this idea, we also try to improve the properties of the gas sensing by incorporating the other the counterparts in not only the carbon material. We also use the silver nanowires along with the nanotubes for improving the properties, where we synthesize the silver nanowires or the grown silver nanowires in the laboratory. And this is the scanning, the transmission electron microscope of the beautifully grown the silver nanowires. And the grown nanowires been tested, and we isolated the nanowires from the morphological stuff like particles and so on in the laboratory. After the growth and the isolation, the pure nanowires been prepared as a conducting ink. Now the silver is not optically transparent, but the conducting ink based on these grown silver nanowires, if we coat it on the suitable substrate, there is a possibility of making optically transparent. Here is the silver, the bucky paper which we have developed after growing the nanowires in our laboratory using polyol process. So shows the quite interesting the the electrical conducting properties, means the 1.9 ohm of this wire derived from the synthesized the silver the ink shows it has the silver metallic property, but flexibility is introduced in the synthesized system. So we thought of making use of the similar idea by combining the silver nanowire and nanotubes, by coating the nanowires on the top of the filter paper, and the CNT is coated again on top of the silver nanowires. So kind of heterogeneous the layer we formed, so that speaks more for better in application. So here is the actual and the simulated images of silver nanowires, on top of which we have these CNT, the single wall carbon nanotubes, which is well disposed. That means the silver and the CNT combination gives you quite interesting improvement in terms of the sensing applications. One interesting thing here is also the disposable. That means very similar to the earlier the sensors. This is also made from the cellulose paper. That means the substrate, and the silver and the carbon is the layer. So it is environmental friendly, so that we can think on developing the new generation devices using this wonderful the combination. In addition to the nanowires on the paper, we also use the glass as a substrate to coat this very thin the layer of the CNT and the silver. That makes the quite interesting results if you supply energy into that by adapting the Joule heating principle, where the I squared R is the simple idea, means the current carrying capacity of the nanotube is very high by reducing the resistance. That's what we did in all the processes. So using this I squared R idea, the Joule heating law, we supplied the small amount of electrical energy into the fabricated film devices that shooted up the temperature well beyond the required temperature. That means the left and the right hand side shows the with and without the silver electrode the coating on the CNT on the glass substrate. That means the conducting layer on the glass substrate demonstrate that the thermographic image showing that the rise in the temperature well uniform throughout the substrate, which can be used as the portable heaters, or you can carry the heat wherever you want. So this idea can be used by transferring this the film on the flexible substrate, where you can wear the heaters or the jackets in the cold regions to protect the ideas, or the localized heating will be helpful instead of the heating the entire environment to save the energy. So here is the interesting the relationship between the applied voltage and the temperature, where we reached about 420 Kelvin on the glass by simply supplying 60 volts. The current involved in this in the order of milliamperes. So the power related to this, the devices is very, very less when compared to the conventional heaters, where we want 2000 to 3000 watts to heat the entire stuff, for example the heaters. So the 420 Kelvin heating with the 60 volt is more than sufficient in realizing the heaters or the transparent heaters. So it can be used as the defrosters and also the transparency can be used to replace the car, the front and the rear views without compromising the optical properties, and building windows and temperature controllers and high transmitted heaters, rear view mirrors can also be possible in using this interesting the idea or the material. And the photograph shows that the frosting and the defrosted, simply the heating process which we have realized well before a minute. That means 52 seconds is sufficient to reach the temperature close to 85 degrees centigrade, which is more than sufficient to evaporate the deposited water-based molecule at the moisture or in the critical environments. Yeah, so keeping this idea, we also gone beyond the level of the CNT, use the synthesized silver nanowires to realize the transparent heaters, where we got wonderful results in using the pure silver wires. That means it will open a new path, either the individual material or the combination of this material to realize the transparent and conducting devices, which will open the new the possibility for realizing the portable devices. So another interesting thing here, after the Nobel Prize from the Manchester University, the couple of physicists in the year 2010, that means the secret of the building blocks of all the nanomaterials, the allotropes, is revealed from this successful isolation of a thin layer or a single layer of the graphite called the graphene. That is going to be a mother for the building block of all the graphitic materials. That means a single layer can be used to create the graphite, and the high pressure and the high temperature, the graphite can be converted into sp2 to sp3 diamond or the artificial diamond like structures, and then the rolled sheets can produce the carbon nanotubes, and the beautiful bucky paper can also be realized by folding the hexagons and pentagons depending upon the number. You can realize the buckyballs or fullerenes like. So after opening this the idea, now we can believe that the future of the graphene, or this could be the discovery of the century, depending of course on how far down it goes. So we thought of the realizing the 2D and one-dimensional materials, which is not conventional in the early days. Now the materials of a new kind, one atom or a molecule thick atomic planes, were known before as constituents of three-dimensional system. Now we are able to isolate, study and use them for the practical or the required the applications. Okay, so keeping this idea in mind, we have gone for the decoration of the graphite layers by successfully isolating a few layers after the oxidation process. We call it as a graphene oxide using the conventional oxidation process, and then the oxidized the graphene or the graphene oxide can be used for creating the new gadgets, which can be used to monitor the biological system, and you can embed it in the body via the IoT. The doctor can analyze what is happening the patients or the group of people using the AA and the possible the IoT connection. Means not necessary to visit the doctor, and if you are low in sugar, if your blood pressure is very high, the senses will give you an indication that you are running out of sugar. You are running out of the pressure. I mean, the pressure is very high. Take some water. Give you some instruction, and the data which is available, which can be stored after connecting with the internet, can be useful in statistically deriving some of the ideas for the doctor without spending much time. So the IoT and the AA, along with this new gadgets, will serve the purpose for the future requirement, particularly for the health and related issues, particularly in developing the body sensors and smart monitoring system and the wearable, the electronic devices, where we have a lot of scope in using this, the graphene and the graphene based the oxide materials or the derivatives of the two-dimensional, the carbon based materials, in addition to the polymeric stuff, either the individual or polymeric. Just to demonstrate this idea, we have taken this PVA and conducting polymer, polyethylene dioxythiophene doped with the PSS, combining these two polymer with the reduced graphene oxide and graphene oxide without using any substrate, this graphene oxide itself is acted as the substrate, where we have coated this PV and P dot, and shined with the lasers will tune the conducting properties depending upon the tuning in the microstructure. That means the microstructure of the polymer P dot PSS is responsible for variation in the conductivity. So by tuning the microstructure, we can tune the electrical properties. So keeping this idea in mind, so we have made the possible combinations in realizing the conducting polymer and the graphene oxide composites, where the local strain induced in this the combination is responsible to achieve the planar or the highly plane surface, and the scrambled egg-like structures, and then the cinnamon-like structures depending upon the amount of the polymer material used in the graphene oxide. So the tuning the microstructure will help us in tuning the electrical and the electronic the properties, particularly on this energy storage related stuff. I mean, look at this, the schematics, the molecules available, the graphene oxide, P dot PSS and the PVA aligned itself by depending upon say the combinations, the microstructure is responsible in tuning the properties. So the various microstructures, we also tested the thermal stability, which also enhances the thermal stability of the graphene oxide. So the improved thermal stability along with the tuning the microparticles or the microstructures gives the wonderful properties in realizing the new type of the energy storage, the cathode or the electrode the device making. So here the reduced graphene oxide P dot PSS and PVA composites act as the microcapacitors in the macroscopic the papers. So that opens the new path in developing the composite material to address the energy storage and related stuff. And here is the last and probably the last interesting applications, the design of the heterostructure in the P dot PSS coated on the GO or the graphene oxide for the UV and the IR detection, where the UV and IR it's not visible to us. So the detection of the UV and IR will also help us in a variety of the applications in science and technology, particularly for this engineering applications, also to think on the electromagnetic shielding and so on. So keeping that in idea, so we created the graphene oxide bucky paper adapting the conventional filtering process. On top of the graphene oxide, we have deposited the P dot PSS, the conducting material, and after the deposition, we shine the high power NdArc laser with the 532 nanometer for a few seconds. That means the shining of the laser is capable of evaporating or controlling the functional groups available on the graphene oxide. So the laser shining will give you the P dot PSS, on top of which we have the reduced the graphene oxide. That means partial reduction or controlling of the functional group will tune the dielectric properties or the semiconducting properties. That makes quite interesting the signal transport while shining the layer in the infrared or the IR. So the infrared and the IR detection gives quite interesting the possibility of making the shielding purposes and the dielectric and microelectronics related the applications like. So the successful isolation or the few layer formation after shining the NdArc laser on the graphite or the graphene oxide layer itself or the substrate itself gives quite interesting 3 layers, 2 layers and 4 layers. That means very thin the graphene oxide the formation open the new possibilities of making the new generation the IR and the UV devices like. So this is the typical temporal response characteristics with against the time for the UV and IR of pure graphene oxide, pure P dot PSS, and then the laser reduced graphene oxide and P dot PSS under the laser reduction. That means each and every process improve the properties in sensing the infrared and the UV. So with this the idea, I would like to conclude the carbon materials research is a mature area but shows no sign of being exhausted. There are plenty of rooms, there plenty of things need to be exercised on the laboratory as well as in the industrial scale. So a lot of opportunities are there, particularly for the youngsters. Those who are interested in the research can take up a few challenges to address the global problem addressed by the Richard Smalley, which is shown in the beginning of the talk. Our interest is, as mentioned, mainly on energy, environment and the health. There are other topics that need to be addressed. So the youngsters can come up and take the challenging the problems to address the global issues like. So I thank my the PhD students and my collaborators and also the funding agency in realizing some of the interesting result from the unusual carbon nanomolecules like. So with this I would like to thank the organizers for giving me this opportunity to share some of our experience particularly on this unusual megamolecular system, what we call it as a nanocarbon the molecules like. Thank you one and all for your patience like. So if you have questions you can.
Questions
Yes.
from participants.
Yeah, one by one, yeah. Yes, it will, but for the given condition and the normal atmosphere, silver is not oxidized. But it is very much true for the copper because the oxidation is very quick for the copper. But the silver is stable for few days and few weeks to realize the applications like. But copper is not. We use this for a few months. It is true. Like, yeah, thank you.
Sir, can I ask in Tamil?
Yeah.
சார் நான் இப்போ புதுசாக ஜாயின் பண்ண ரிசர்ச் ஸ்காலர் சார்.
ஓகே.
என்னோட ஃபீல்டு வந்து அசைன் பண்ணியிருக்கிறது இந்த கார்பன் டாட்ஸ், எஸ்பெஷலி பயோமாஸ் கார்பன் டாட்ஸில் சார்.
ஓகே.
ஸோ எங்களுக்கு வந்து அப்ளிகேஷன்ஸ் என்னென்ன போகலான்னா பயோ சென்சிங், FE3+ சென்சிங்கில் போகலாம் அப்படின்னு சொன்னாங்க.
ஓகே.
பட் நீங்கள் அந்த ஹீட்டிங் பற்றி போட்டிருந்தீங்களா சார், அது ரியலி இன்ட்ரெஸ்டடாக இருக்குது சார். அதில் என்ன கேட்குறேன்னா,
ஹீட்டிங் இஸ் நாட் ஃப்ரம் தி கார்பன் டாட்ஸ். ஹீட்டிங் இஸ் ஃப்ரம் தி CNTs.
Yes sir. So இப்போ நான் கார்பன் டாட்ஸை இந்த இதுக்கு கொண்டு வர முடியுமா? That's my question sir.
Yes, it is a quite interesting question, but the point is if we have a mesh like carbon dots is a particle where the connectivity is the problem. If you deposit more carbon dots on the film, then the connectivity is possible. And the carbon dot mostly of semiconducting materials, it is not of metallic properties. Whereas the wires like silver wires or the carbon nanotubes, it is of metallic property. This metallic property will help us in improving the electrical conducting or by bringing the low resistance which is wanted for the joule heating stuff, right? So directly to answer your question, the particles it's not that much useful for realizing the conducting layers because you need conductivity, whereas the power it is I squared R, high current carrying capacity with minimum resistance. I squared, that means the square of the I can be used, I mean current can be used for the heating purpose. So it is not a good idea to use this carbon dots for the heating purpose, whereas you can use for the other possible purposes.
And one more thing sir. So when my supervisor assigned this one, I was like, why I have to go? There is not that much field. But after seeing your lecture, I'm just very keen to work in my upcoming future. Thank you for that.
Good. So there are a lot of, rooms need to be opened, so need to be checked. So the darkness of the carbon side is plenty. You can make use of that for illuminating those rooms by identifying suitable problems through your supervisor. All the best. Yes, sir.
Sir, I have a question. Thank you, sir, for giving a wonderful lecture. So I have a fundamental question. So you are talking about carbon nanotubes and they are confined, quantum confinement. So what happens in field emission? So when you keep carbon nanotubes in an electric field,
Yes.
it continuously emitting electrons. So can you shed more light on this?
Yes. Basically, it is the quantum emission. So the follow-noidion, the idea is responsible for this continuous the field emission. So here the carbon nanotube, it's basically a robust. If you closely look the scanning electron microscope, it is not a nanotube. It is a robust structure. That means 0.5 or 1 micrometer thick rod, but still we call it as a carbon nanotube because the top of the carbon nanotubes, the thick robust rods, it is in the order of few nanometers. So this few nanometer is responsible for the electrical discharge if you are supplying negative bias at the electrode or at the bottom. So once you supply a few voltage, this electron can be ejected from the tip. What we need basically an electron source to accelerate to generate the X-rays. That idea we have used it. Since we are not heating the substrate, we call this as a cold emission, otherwise known as the quantum emission line. Okay. I guess I have answered your question.
Yes, sir. I could understand something. But so in an atom, how an electron is made free? By just applying an electric field.
So it's a good question again. I can treat this. This is nothing but a metal. I can assume that an analogy, you have a sharp metals. The sharp metals is capable of ejecting the electrons. It means a lot of free electrons are available on the surface of the metal. Here we are considering this, the nanotube, as like the conducting metals. So metal is known for the free electrons, right? It's a ocean of electrons. Like.
Okay, sir. Definitely. Yeah. So it is one of the important property of nanomaterial,
yes.
nanotube.
Yes.
Thank you, sir. Thank you very much.
Yeah.
Sir, I have seen one biomass carbon dot paper, sir.
Yeah.
So the main use of
Yeah, biomass will give you the production of the carbon dots, but the controlling of the type of, because carbon dot, it is a very general name. In carbon dots, we have the carbon particles, say the carbon polymer dots, we have a graphene dot, we have a graphene quantum dot, and variety. There are 5-6 different varieties, probably you might have aware of that, and it is very difficult to control from the biomass. And another interesting thing here in the biomass is you can produce nanoparticles, I mean the CDs, but the isolation and the purification is the big challenge. And as you rightly pointed out, this the incorporation of the heteroatom like nitrogen, sulfur, phosphorus, boron, and you need to incorporate all these things by incorporating the suitable heteroatom sources, which is pretty difficult in the biomass, but it is possible. Yeah, so it is a very deep-rooted question actually, because we used to say in the carbon, it is not a pure carbon material. Always you will be ended up with the oxygen to certain amount, nitrogen to certain amount, both the left and right hand side. You see in nature, carbon is not alone forming the natural stuffs like organic. It used to combine with the hydrogen, nitrogen and oxygen. It is true to the carbon world itself, I mean the material, carbon nanomaterial world. So instead, we used to check the CN ratio, CO ratio and CC ratio, that means sp2 and sp3 and so on for the quantification. So that probably help you in, yeah. So it is quite challenging in controlling the other heteroatoms, but it is possible. Yes. Thank you. So any other questions? Okay. Thank you.
So really it was a nice presentation given by you, sir. How your field is play a role in applications wise in engineering field, especially in mechanical and communication field, the wearable devices and in medical field, how so far that applications are used by using this nanofield. It was an awesome presentation. Thanks to Dr. Manivannan sir, who has given an awesome presentation in the session. Thank you, sir.
Thank you.
Thank you for your wonderful presentation, sir. May I invite the chairperson to honor the keynote speaker of the session. I invite Dr. Kumar sir, Principal of Vinayaka Missions College of Pharmacy, to honor Dr. M. Nitya, Vice Principal of Vinayaka Missions Kirupananda Variyar Engineering College.
Sir.
Thank you, sir, and thank you, ma'am. I invite Dr. Shankar Lal Garg, FRSC, FWRA, ex-principal of Holar Science College, Indoor and editor, Research Journal of Biotechnology. I also invite the chairperson of the session, Dr. Kumar. He is a principal of Vinayaka Missions College of Pharmacy, to chair the session, sir.
Very good afternoon to Nadu. I feel great pleasure to introduce Dr. Shankar Lal Garg, who is a reputed personality of the world with rich professional experience in different aspects of science and research, and also in the development and teaching and supervising, planning and administration, and also institutional growth and international corporation, etc. Dr. Garg is recognized as a well-known environmentalist, eminent scientist, good researcher, and bright academicians, having sound administrative forum. He is a person of integrity, visions, and foresight of led any institute to new heights in qualitative as well as quantitative growth. He has skill to work with international people, and he can collaborate with the international, foreign government and other organizations. He has won national and international recognition as an environmentalist and good researcher and excellent teacher. He was awarded Anak Sarawat Award.
It is enough.
It is enough. And also I know very well, and sir is having several capacity in the editorial board as a various research paper, and also several awards received. With this short notes, I request Garg sir to present your presentations.
Honorable Chairman and dear friends, very good afternoon to all of you, and I am so pleased that your principal has invited me to talk to you. I am not delivering a research article, so I invite all my young friends, please come ahead and don't use your mobile. Please come on. My talk is just for you. Please come on. If you are a good student, please come ahead and close your mobiles. You don't follow your elders. You have not been taught like that. Anyway, it is up to you. No, I want my abstract. You see, the whole world is suffering from pollution, environment, loss of biodiversity, ozone depletion, climate change, and so on. Are you making any efforts to fight this? Anyone? Anyone who is fighting for climate change or who is fighting for increasing the biodiversity? What biodiversity means? Biodiversity means everyone should live together.
whether it is human, whether it is animals, whether it is plants, whether it is butterfly or anything. And the present state where we are living, we are losing so many species of plants and animals and birds and all that. And the day will come soon. You are in Salem, so you are able to see blue sky. But a day will come in Bangalore or in Bombay, you don't see blue sky. And after say 10 to 20 years, people will forget that there used to be a blue sky. There used to be a blue ocean. There used to be a snow-clad mountain. So who is responsible for it? We are responsible for it. So I just want to teach you, because I am not just teaching, because I have practiced it, and so I have a right to tell you that you must also practice it, right? So the cure for everyone, all these bombastic words like climate change, ozone depletion and all, is that you go for plantation. What a plant offers? Plant offers you fresh air, plant offers you water, plant offers you fruits, plant offers you a good economy, and it prevents all the disasters. No floods, no drought, no landslides and so on. So there are so many uses of a plant or a tree. If a well-grown tree, say of 10 to 15 feet height and 15 to 20 years old, gives you oxygen worth 12 lakhs. A plant gives you, or a tree gives you oxygen 12 lakhs worth. And it absorbs carbon dioxide and other material worth 23 lakhs. So if a tree is 20 years old, it is saving you 35 lakhs. 23 lakhs for carbon dioxide absorption and 12 lakhs oxygen. Please don't laugh. Either be serious and listen to me. Because I am crusader for this one. I have come here only that you guys should get inspired. I would have given you a theoretical lecture, but I don't believe in that. So everyone should try that biodiversity should be increased. Lord Mahavir used to say, live and let live. Or even Gandhiji also said that, live and let live. Everyone has the right to live. So if I can do it, you can also do it. You can have so many examples in the world where people have grown up right from scratch to anything. If you are, say, interested in cricket, recently we have come across Yashasvi Jaiswal, just 23-year-old boy. He used to live in the pavements of Bombay and he used to sell that pani puri, but now his worth is 25 crores. So just by playing cricket only, because it was his inspiration that cricket and cricket, nothing else. So if you are also determined that you should have a good quality of life, then you should be determined. I'll produce, I have planted 50,000 trees after my retirement. I am 75 years old at present, and in last 9 years, I have planted 50,000 trees on a barren rocky hillock. All these plants were planted on rocks, and plants have so much power that they have converted rocks into soil. The hillock which I planted did not have water. I purchase water every day, but still the plants are growing. Let us see. I have named it as Kesha Parvat. Okay. So this is the present state of affairs. You can see a lot of greenery, right? This one? Yeah. Can it go that side? Or I go that side? So we don't add any fertilizer, we don't add any pesticides, we go for natural farming. Why? Because God gives enough fertilizer when it rains, when monsoon comes. Okay, I go for next. You won't be able to see the text, I think, because you are sitting far behind. Yeah, this is the present view of 2025. Greenery of 2025, we have planted 50,000 trees of 600 species, various types of plants. You see the greenery. And how we started? This was the land in 2016. Can you believe that this land, the conversion in last 9 years, and that too on the rocks. This was the present state in 2016. You see full of rocks, full of barren. Again see, if you see this surface, then you see that you can't dig it by the Fowla or Geti. You need that JB, what you call? JCB. The machine which digs the, JCB. So the holes can be done only by JCB, otherwise not possible. So we have just planted the trees on this rocky hill just by putting the soil over there and just planting. So even then they have grown up. So our mission is now on completion. This is a 22-acre land and our aim was to plant 50,000 trees. Right from apples to cashew nut, we are growing everything. The journey began in September 2016. You can see the land. This is 2017-18. 2018-19, I have been given only 20 minutes because the organizers are running very late. This is 2019-20. In 4 years, there was some greenery. And as the years increased, the greenery also increased. 21-22, this is 22-23. We have all type of flowering plants, we have all types of fruits, except kiwi. I have got all the fruit plants, right from avocado to olive and everything. Greenery of 2024. So how we started, that I have just told you. Why we named it Keshe Parvat? You know that saffron is grown only in Kashmir in India. But we are also growing saffron in Madhya Pradesh at Indore at 43 degrees centigrade. We are not having 5 degree or 6 degree temperature as it used to be in Kashmir. You just see the flower. The flower of saffron is very beautiful with 3 leaves. Then we have got all that wood trees, teak wood, banyan, rosewood, chandan, everything. Sal, anjan, bamboo, willow, devdar, dahiman, khamar, and out of these many are now extinct varieties. This is dahiman, this is willow. You know, willow tree grows in Kashmir only or in Britain, but it is growing at Kesher Parvat as well. Cricket bat is made up of this willow tree. Then we grow fruits. In the first one you can see apple, then custard apple, then this is dragon. Then falsa, you must not have heard here because falsa does not come in the south. It is mulberry. Then here we have got cashew nut. You know cashew nut. Then this is olive. Olive grows only in Spain and Italy at 4 degree, 5 degree centigrade. But our Keshar Parvat grows them very well. This is Amla. Then we have got flowering trees, African tulips, Paras people, Kachnar, Amalthas, and so on. Then we have got medicinal plants. Means if I have got 50,000 trees of 600 varieties, then on every species you can do medical research. Because nowadays all pharmaceutical companies have shifted their research into plant research. And there are no side effects. So if you want to do research, I will advise you to go for plant research, plant-based research. This is cardamom, this is baheda, this is insulin plant. Earlier, just eat the leaves of this plant every day and you will be free from diabetic. Otherwise, you have to put so many synthetic injections and medicines and so on. Then general trees, this is Rudraksh, Sindoor, Kalpraksh, Putra Jiva. Kalpraksh is also an ideal tree. Anyone knows about it? No. Kalpraksh was obtained from the Samudra Manthan when those demons and devatas were fighting. So if you go to this tree and just hug it and ask anything for it, your wishes get fulfilled. So this is Kalpraksh, this is Putra Jiva. I have made a pond as well, poly pond, man-made pond. Everywhere there is plastic and there are birds, there are fishes and all that. You see, whenever there is a greenery, greenery means green line, there must be a blue line as well, means there should be water. If you go to any place and if you see greenery as well as water, you feel elated. And we have to make a compromise because nowadays 3 lines are there, grey line, blue line and green line. Grey line means this concrete jungle. You can see the surface behind the earth. This was all rocky. It was a well designed by us and now we are having water in it. Earlier it was very dry, the left one. These are the birds and butterflies we are getting here. Means 10 days are back, we were not having a single bird. We were not having a single tree. Only we have planted and that barren rocky hillock has turned into a beautiful dense forest. So you can see birds and butterflies. We also get wild animals like jackal, nilgai, scorpion. And if all these are extinct, the humanity is doing like that, then humanity will also not survive. Ours is a spiritual place. You can go meditate, you can feel with nature, you can feel one with the God. You can enjoy sunrise, you can enjoy sunset. And I already told, the tree does everything. It cures you from various diseases. Various people came to see the Keshar Parvat. If you are in Madhya Pradesh anytime, you are most welcome to visit Keshar Parvat. You just type in the Google Keshar Parvat, you'll get everything. This is a lotus pond. 20 minutes over. Hello. So, I just want that at least plant one tree. I am not asking more than that. But plant one tree and maintain it. That is very important. In our area where you see the rocks and all that, survival rate is 95%. Death rate is 5%. Otherwise, what happens every time? Death rate is 95%, 5% is the survival rate. So, you see that I used to believe, I am not a botanist, I am a student of chemistry. What I believed is that if a person can live in America, or an American can live in Bombay or in Bangalore or in Hyderabad, then the plants should also live in India. The American plants should grow in India. The Kashmir plant should grow in my place. The Kerala plant, cashew nuts, should grow in my place. So that happened. Just you have to see or you have to maintain that you can do it. So if you think that you can do it, you will do it. So the only thing India is asking that greenery, greenery, greenery. You have to save India from climate change. If 1 degree also rises, say normal temperature, we can say 38 degrees throughout India. So if 1 degree rises, say by 39, it becomes, nowadays it is becoming 44, 45. In my place at Indore, temperature is 43 degrees always. So if temperature goes up from 38 to 39, you see everyone is using air conditioners and all that. So 7 lakh watts units are to be consumed every day extra. Who will pay for it? Who will maintain for it? Who will prepare for it? So go for nature, plant as many as trees as possible. If you go to the World Economic Forum, then World Economic Forum wants that every Indian should plant at least 125 trees by year 2030. I know that it is not possible for Indians to grow 125 trees, but at least grow for 1 tree each year. So that I hope you can do, and therefore I was asking you that please maintain it. If you do this, you will do well in the research. You must go for practical one. Research should also be practical. Research should also be for the society, for betterment of mankind, and for betterment of the nation. It should not be oriented to me or to you only. So whatever we do, it should be for the society. So please keep in mind that you live for the society, you live for the well-being of all, and you have to maintain that live and let live. Thank you very much for patient listening to me. If you got any questions, you are most welcome. 20 minutes over? Okay. Or you can ask me afterwards, or you can ask me even at my mobile number you can write if you are interested, 94250-56228. 94250-56228. So wherever you find an empty space, try to plant something, not the roses and the grass. Try for a bigger plant, because bigger plant saves you from all the disasters. Thank you very much.
Thank you, sir. Thank you for your suggestion to the audience. And really we congratulate, after retirement as a principal and pro vice chancellor, you have planted more than 5,000 trees within 9 years. Really we appreciate. That's why you are becoming a not only editor of other journals, you are also editor of some American Journal of Climate Changes, American Journal of Earth Sciences, and Journal of Clean Water, Air and Soil. And also I appreciate, and what sir told, no, you can, at least you can follow. You plant 1 tree in front of your house or anywhere else near to your house, in the park or any place. So if you are placing 1 tree in front of your house, you will get nice breeze, carbon dioxide free, you will get more oxygen, very good oxygen, you will breathe, not only you, your family, and also it is good for our nation. And thank you, sir, thank you for your presentation.
Thank you, sir, for your wonderful presentation. Now I invite the chairperson to honor the keynote speaker. Thank you, sir. Now, may I invite Principal of VMKV Arts and Science to honor the chairperson of the... Thank you, sir. Dear attendees, lunch has been served outside of the auditorium. You can go and join the lunch and you'll be back at 2:15. There will be a parallel session. It's going to be conducted in auditorium. Those who are having a PPT presentation, kindly hand it over your PPT. Lunch session is about to start. I would like to invite the jury of the session, Dr. Sendil Kumar, Professor and Head Department of Physics from Vinayaka Missions, Kirupananda Variyar Engineering College, Salem. It's over to you, sir.
Thank you, madam. So good afternoon to one and all. So now I invite the first presenter. The title is Green Synthesis and Characterization of Silver Nanoparticles. You start, madam.
5 minutes. Okay, fine. Okay. Good afternoon, you're now present here. Myself, Jeeva Jyoti, Assistant Professor, Department of Pharmacy Practice, Vinayaka Missions College of Pharmacy. My title is Green Synthesis and Characterization of Europhobia heterophilia L. These are all my contents: introduction, materials and methods, result and discussion. In materials methods, there is extractions of silver. These are all the materials and method. First step is the extraction of plants, and then synthesis and characterization. In characterizations, we done the in vivo studies of MCF7 cancer cell lines. This is the introduction. Nanotechnologies are all well known that it is very developing and new technology used in the research fields. In that, I particularly choosing the silver nanoparticles, especially due to the targeted drug delivery system and antimicrobial and antibacterial properties of the studies. In this, we specifically see the breast cancer, because cancer is a leading disease in the world around. Especially breast cancer means it is a second leading death cause of the women, especially in women. Cancer is the leading cause of death. So I particularly focus on the breast cancer by inducing the plant derived products. I choose as the plant Europhobia heterophilia. This is the medicinal plants currently using in Ayurveda and Siddha currently. And now I introduce these Europhobia heterophilia in silver nanoparticle synthesis for breast cancers. This is the plant profiles. It is under the family name of Europhobiaceae. It's Tamil, it's called as pal periki, and English it's called as milkweed, because in this plant the milk secretion is high. Currently they are using this plant for milk secretion, increase the milk secretions for both humans and also for the animals. This is distributed tropically and subtropically in the worldwide, and the part used is whole plants is used. Myself, I particularly use the aerial parts only, except roots I use the aerial parts of the plants. These are all the literature reviews. Currently only the literature reviews are done. Only they used biosynthesis of nickel oxide nanoparticles, but in study I used silver nanoparticles. Okay. Sorry. This is the materials and methods. The first steps is extraction. The fresh plants was collected and dried completely under sunshades, and we powdered it into coarse particles. Then we go for the oxalate extractions for 72 hours. After the extractions, the complete, we use aqueous extraction, water as a solvent for extractions. Then we collected the extracts and we filtered it by using the 0.45 micro nylon members due to the pore size, because filter paper has more pore size than the nylons, so we uses the nylon silicons. Then we synthesized. The collected extracts was mixed with the silver nitrate stock solutions by 3 mm preparations, and it overtakes, and with continuous stirrings it takes 3 hours times, and the color change from reddish brown indicates the formation of silver nanoparticles. And we undergo for the characterizations under UV, FTIR, SEM, TEM, and in vivo cytotoxicity by using MTTA assay. This is resultant discussions. It shows the clear absorption range from 410 nanoatom to 465 nanometer. This is the FTIR studies, and it shows the band from 16333 centimeters, and due to the presence of carbonyl groups, and it shows the structural vibrance of CH bonds and 3299 centimeters along the OH bonds. It completely shows the how the components present in the urophobia heterophilia clearly. This is the TEM and SEM analysis. It showed 20 mm. This is the MTIA results, anti-cancer silver nanoparticles from the aerial pods. We using positive controller cyclophosphamide. Compared to it shows 300 microgram concentration is very effective, equal to the control studies 94.65. It's 69.45. The summary and conclusions is in the study, the aqueous extractions of urophilia heterophilia were synthesized into silver nanoparticles by using oxalate apparatus up to 72 hours. The synthesized silver nanoparticle was characterized by various methods like FTIR, UV, SEM, TEM, in vitro cytotoxicity against cancer cell lines, and it's, the silver nanoparticle was spherical in shape and uniformly distributed. Its size ranged from 50 to 100 nanometer. It was confirmed by the same TEM analysis. The presence of phytochemical constitutions was confirmed by the FTIR study, and the in vitro cytotoxicity study shows the 87% of cell viability against breast cancer cell lines. MCF cell line is one of the cell lines we are using for the most commonly using for the breast cancer cell lines, and this study indicates the anti-proliferative activity of silver nanoparticles is dependent on the shape, size, and the nature of capping agent. These study silver nanoparticles may found to be applicable for the future breast cancer treatment. These are all my references. Thank you. Any questions?
So, any questions from the audience? So silver nanoparticles is already used in many studies. So
yes.
How your study is different from that?
Sir, because we are using different plants. In this urophobia heterophilia, it sometimes it is a laxative plant, so it depends on the dose. It varies from the like activity. Nobody is using urophobia heterophilia plants, so we are incorporating the silver nanoparticles.
So what is the local name for that?
Pal periki.
Pal
periki. The name itself, so pal periki. Increase the milk secretions. It currently using for goat, cow and other animals to increase the milk secretion to the motherhood. In humans also they are using in Ayurveda to increase the milk secretion. So already the plant acts in the mammary gland. So we can induce it by targeted drug release system. It can be used for the breast cancer. So it also showing viable results against the cell cancers. So next we are further going for the in vivo studies against breast cancer.
Okay. Have you made any publication regarding this?
No sir, still it's going on. It's under, after completing in vivo study, we are going to publish it, sir.
Thank you, madam. Good.
Thank you, sir.
Thank you for your presentation. The next presenter is OPESE09, OPESE46, OPESC 47, OPESC 48, OPESC 49, OPESC 50, OPESC 51, if anybody willing to present the PPT. You are willing, ma'am?
Madam, unga name mattum edukku. இந்த லிஸ்ட்ல இருந்தது உங்களுக்கு இல்ல சார். நான் பார்லர் செக்ஷன் ஒண்ணுனா போடுறேன். இந்த நேம் எடுத்துங்க.
If anybody is having a PPT,
Hello. Can I start, sir? Can I start? Good afternoon. Good afternoon to one and all present here. I am Vanitha, research scholar part-time in Vinayaka Mission University. I am going to present formulating a beta-cyclodextrin dasatinib inclusion complex by needing to boost dissolution performance. The contents to be covered in the presentations are introduction, materials and methods, results and discussion, summary, conclusion, reference and acknowledgements. First, we come to the introduction. Dasatinib is a tyrosine kinase inhibitor which targets and blocks kinase families including BCR, ABL. in treatment of Philadelphia chromosome positive acute lymphoblastic leukemia and chronic myeloid leukemia. Dasatinib, which has BCS class 2 drug, it has a low aqueous solubility. In our investigation, we have enhanced the solubility as well as the dissolution by adding beta-cyclodextrin through kneading method. Beta-cyclodextrin is the most chosen host for most drug molecules because of its improved wetting, reducing crystallinity and microenvironmental partitioning. Cyclodextrin is effective for pre-absorptive facilitation and also enhance the solubility as well as dissolution rate of poorly soluble drugs. The materials are dasatinib, beta-cyclodextrin, ethanol and distilled water. Kneading method is used to prepare the beta-cyclodextrin and dasatinib at the ratio 2:1 ratio, that is optimized ratio through kneading method. First we take the beta-cyclodextrin and DOS 2:1 ratio in a mortar and the solvent like ethanol and water added dropwise to the mixture. After 45, this will be continued for 45 minutes until like a paste. After 45 minutes, it will be dried at room temperature for 24 hours. After 24 hours, again grounded well and passed through sieve number 65 mesh and until store for further use. Results and discussion. Based on phase solubility diagram slope, we determine the stability constant. Then based on Jobs plot, we determine the stoichiometric ratio. The highest peak shows 0.7. At the optimized, so we confirm the optimized ratio is 2:1 of beta-cyclodextrin and dasatinib. The percentage of drug release, that is in vitro drug release, determined between pure drug and inclusion complex. The blue color line indicates pure drug and the red line indicates inclusion complex. The inclusion complex shows higher solubility compared to pure drug at over 120 minutes. Then some image labeled ABC shows surface morphology of dasatinib, beta-cyclodextrin and inclusion complex. Image A shows well-defined crystalline plates with sharp edges. And the beta-cyclodextrin shows irregular shape. It is the surface cavities favorable for entrapment of guest molecule within the beta-cyclodextrin during the complex formation. Finally, inclusion complex. In the inclusion complex, see image, it shows original crystalline peaks are, the crystalline plates are completely disappeared. It confirms that it has been, confirms the successfully incorporated within the beta-cyclodextrin. FTIR studies used to chemical incompatibility studies between three compounds. There is no interaction between these three compounds based on the functional groups. Next, differential scanning calorimetry presented here. Image A shows pure dasatinib. It shows sharp endothermic peak at 286 degrees Celsius corresponding to its melting point. And B shows beta-cyclodextrin. It was broadened and to 93 degrees Celsius due to dehydration of bound water molecules. And the inclusion complex in dasatinib completely disappearance due to loss of crystallinity. The chemical shift also changes. Finally, proton NMR nuclear magnetic resonance. The upper spectrum shows the aromatic and aliphatic with the proton signals, and the lower spectrum shows the inclusion complex. Compared to A, the inclusion complex shows chemical shift changes and proton signals was observed. It indicates the host guest incorporate within the beta-cyclodextrin. Then finally, X-ray diffraction. X-ray diffraction, image A shows beta-cyclodextrin shows broadened peak characteristic to its amorphous states, and the B shows sharp, dasatinib shows sharp crystalline peaks, diffraction peaks characteristic to its crystalline nature, and the inclusion complex shows the peak was reduced and broadened, so it successfully enhanced the solubility and dissolution rate. Summary. Through kneading method, we prepare the 2:1 ratio beta-cyclodextrin dasatinib, and it is proved to simple, efficient approach to overcome dasatinib BCS class 2 limitations. space solubility, Jobs, Kikuchi corners are confirmed that 2:1 ghost-to-ghost is stoichiometric with binding affinity. Solubility, pure drug shows 14 microgram per ml and the solubility increased nearly threefold, 40.15 microgram per ml. It also increased the dissolution rate from 35.9 to 76.9 at 120 minutes using buffer as a medium. FTIR, DSC, XRD sum confirmed the inclusion and amorphization. Proton NMR indicated supporting encapsulation. Overall beta cyclodextrin complexation by needing enhanced DAS dissolution. So it suggests improving oral bioavailability and approach to other poorly anti-cancer drugs. Few references I quoted. I sincere thanks to Vinayaka Mission Pharmacy College, Erode College of Pharmacy and PH College of Pharmacy to support to carry out this research work. Thank you, sir.
Okay, madam. So any questions from the audience? So I am having some fundamental questions. So why are you talking about dissolution?
Because dasatinib has a poorly water soluble drug, sir.
Okay.
Suppose we can increase the solubility, the dissolution also increased, sir. At the end of 120 minutes, that is 2 hours. Our approach to increase the solubility and dissolution of dasatinib using beta cyclodextrin, sir.
Okay, so in the context of pharmacy, you want dissolution is important. The medicine should be dissolved in blood vessels.
Yes, sir.
Okay, madam. Okay.
Thank you, sir.
Thank you.
A very pleasant noon everyone presented here. Myself Shubhatra, studying BTech Pharmaceutical Technology, second year in Nanomaterials College of Technology. Now I am here to present the topic unpacking of pharmaceutical products. Let us discuss brief about this topic. First, the definition is the pharmaceutical product is a science and art of technology to enclosing protecting products for distribution, storage and safe and use. Packing also refers to the process of design, evaluation and production of the packages. And the ideal packing requirements are, they must be protect the preparation from the environment conditions, and they must be reactive with the product, and they must be import the product taste and odors. It must be non-toxic and must be approved by FDA, and they must meet applicable temper-resistant requirements. They must not be cause of product degradation. They must be adaptable to commonly employ highly speed packing equipment. First, the product must be prepared from the environment conditions like moist and etc. And they must not be reactive with the other products. They must be impact of the product. There should not be a change in color or odor. Firstly, the product must not be toxic. Each product should get approval by the FDA, and they must meet applicable temper resistant and requirements. They do not cause any degradation. There are major types of packing. First is primary packing, second is secondary packing, and third is tertiary packing. The first one is primary packing, is the material which envelopes the product and holds it. This is usually the smallest used for distribution, and is the packing with the direct contact of the content. Like for example, ampoules, containers, blister packing, strip packing, and the syringes. You may see that the type in primary packing, syringe, and the second one is the blister packing, and third one is the strip packing. And the fourth one is injection. They are packed in ampoules. And next one is the secondary packing. It is defined as the packing lies outside the primary packing. It is perhaps used to group primary packing together. For example, these materials are packed in cardboard, paper, and boxes, and etc. This is a secondary package of secondary packing. And the tertiary packing, the packed materials and the tablets are packed in a box or a container for transport purpose. And there are types of packing materials: glass, metals, rubbers, plastics, and fibrous material, films, and laminates. Glass is one of the packing material. It is widely used in pharmacy because it is easy to transport and non-corrosive. The glass is composed of sand, soda, lime ash, and cullet. It is made up of silicon, aluminium, sodium, potassium, calcium, magnesium, and zinc. They are used in preparation of, there are 4 types of colors of glasses: amber, yellow, blue, and green. These glasses are used for various purposes. Mostly the glass is used in pharmacy because they are very hygienic, very sterile. They are non-reactive. They can accept the variety of the closures, and they can be used high-speed packing lines. They are easy. They are very transparent, and they have good protection power. Like this advantage, there are some disadvantages. It is relatively heavy. The glass can easily broken while transporting. Realize the photosensitive drug cannot be protected in the transparent glass. There are 4 major types of glasses. Type 1 is a neutral and borosilicate glasses. They are very transparent. And type 2 is soda lime treated glasses. And type 3 is type NP glasses are general purpose of soda lime glasses. And the 4th one is colored glasses. They are in red color, blue color, green color, and amber color. These colors are given for some other purposes like non-corrosive, and they may react with the sunlight and some other environmental purpose. And the second material is plastic. Most of the pharmaceutical materials are packing in plastics. Widely, they are solid of composite material which are longly organic and they are synthesized based upon synthesis resin, and they are easy to transport. The plastic can be cast and molded into various shapes. There are two types of plastic, thermoplastic and thermosetting plastics. And the advantages is plastic is a very low cost and lightweight, easy to carry, flexible, facilitating product, odorless, inert of more chemicals, unbreakable, and because glass is breakable, glass can break easily, but it is unbreakable and leak proof. It is able to retain their shape and throughout their uses. Handling and transportation is easy. And the disadvantages are they are chemically inert as type 1 glasses. They are not impermeable gas and a vapor as glass. They may possess electrostatic charge which attract with the particles or the content. Packing of the dosage form. There are 5 types of packing: solid dosage form, liquid dosage form, sterile product, ophthalmic dosage form, aerosols. The first one is a solid dosage form, like tablets, capsule and powders. They are packed in glass bottles. Before we saw that type 3 glass like soda, lime and non-parently glasses are used. Transparent and amber color glasses are used for some chemicals and to pack syringe powders and chemicals. And plastic bottles are made from polyethylene, HDPE and polypropylene, polystyrene. It is lightweighted and unbreakable. The unit dosages are 2 types. First one is blister packing. You may see the blister packing in most of the tablets like paracetamol and etc. The primary compound, there is a cavity and the caps on the tablet is covered with some aluminium foil. And the second one is tipped packing. This is made up of paper and some plastic and foil combination. Ophthalmic dosage form is plastic. They are like eye drops, ear drops are packed in ophthalmic dosage forms, and aerosol dosage form consists of a thin plated container like spray, and some paint relief sprays are packed in that aerosol dosage forms. That's all.
So, in questions from the audience? So, you have presented about packaging and all. So, what is the novelty? So, what is the new thing you want to tell? So, all those things are present in the literature itself.
Sir, however, how much the medicine is used, also the packing is very important. If a company is if a industry is packing a medicine, it is not only based on the packing. It also it is fully based on packing. If how the medicine or the product is packed and how it reaches the customer safely without any contamination or any other damages.
Okay, so what do you want to say? How to improve this packing? So some novelty, at least one point you should try to express. So you may have some idea. Are you having some idea to improve packaging? You can tell that. So that should be highlighted.
Sir, we may avoid using more plastic materials during this packaging because there are lots of disadvantages. We may use degradable plastics like aluminum foils and many other etc. We can use like this. Avoid plastics more while packing.
Okay, so you are telling about the disadvantages. So what you can suggest some solution by avoiding plastics, what we can do. So that is the thing that should be highlighted. Okay, ma, good. '73.
So good afternoon, sir, and good afternoon to all of you present here. We are honored to present our paper, and our topic is about cytotoxic evolution of green synthesized nanoparticles from cuttlefish ink against the breast cancer cells. So basically our aim is to synthesize the silver nanoparticles from the cuttlefish ink and to test their cytotoxic activity against the breast cancer cell using MTT assay. So we all know that cancer is the mostly spreading in our world, and in all those types the breast cancer is one of the most common thing, and it is the one that is mostly diagnosed, and as well as it is the one that causes frequent death in cancer in women globally. So currently there are several treatments such as chemotherapy, radiation and target drug. All those are effective, but also there must be some natural extract things to alter this existing treatments, so that the patient does not undergo or face drug resistance or other severe side effects. So this is where the nanotechnology has played a big part. Nanotechnology, here we use the silver nanoparticles. It has gained more attention because of its antimicrobial, antioxidant and anti-cancer property. So this silver nanoparticles can be synthesized with several chemical techniques as well, but they cause environmental hazards and also some chemical toxicities. So we use the cuttlefish ink. That is a cuttlefish ink. It is a marine product, sir. It is rich in melanin, protein, and it is more bioactive, so that it has many main potential against cancer cells. Here we use the MTT assay to analyze this. And firstly, the process involves synthesis of the cuttlefish extract. This is an biodegradable, useful, and sustainable, and it is also non-toxic. The synthesized ink extract is then treated with reagents such as MTT and acid propanol. Here we take majorly 3 tests, in which the first is the control test, where cancer cells are kept as it is, so that its viability is 100%. And secondly, we used a standard drug called epitocide. It is used to treat cancer generally. So we use the drug as a standard, and then we use the silver nanoparticles from cuttlefish ink in different concentration to analyze the cytotoxicity. Here, after the cancer cells are treated with all these silver nanoparticles, it is incubated with MTT for 37 degrees Celsius for 3 hours. So basically what MTT does is, it converts the living cancer cell into crystals, formazon crystals. These crystals is then solubilized in acid medium, and their absorbance is read in a biorad microreader. This shows if the absorbance is decreased, the cell viability is also reduced. By this we can understand if the nanoparticle works on the cell or not. So as I said, first is the control test, where only the cancer cells are kept. In this, the OD value was 1.695, and it showed 100% viability. And then we used the standard drug, where the OD value was 1.084. That is, the cancer viability decreased to 36%. That is, it also shows strong cytotoxic effect. But when we come to silver nanoparticles, we use different concentration, that is ranging from 50 to 250 μg. In that, there is a gradual increase of the cytotoxic effect. So from this we can observe that 32% of the cells are only viable, and it decreases the cancer cells viability. Now let us see in detail about the results.
The observation is the silver nanoparticle showed dose-dependent inhibition of breast cancer cell viability. From the first picture, the control cell have more cell viability, and the second picture is the cells are treated with 250 mg of silver nanoparticle. So the cell viability is decreased. The bar graph shows the x-axis is concentration of silver nanoparticle, the y-axis is the percentage of viability. These are the different concentration, and that is the result. From this we confirm cytotoxic effect. When the concentration of silver nanoparticle increases, the cell viability decreases. So we conclude the source is cuttlefish ink extract. The target is breast cancer cells. So the lower concentration is minimal cytotoxic effect. The higher concentration is reduced cell viability. When the cancer cell react with silver nanoparticle, the cancer cell release reactive oxygen species. This indicates the dose-dependent cytotoxic effect on breast cancer cell. So the summary and conclusion is the silver nanoparticle synthesized from cuttlefish ink. The MTT assay confirms dose-dependent cytotoxicity effect. The highest tested dose is 250 mg. So the cuttlefish ink is therapeutic agent for cancer research. These are the reference. Thank you.
Thank you. So questions from the audience? So you are talking about reducing breast cancer effect, using that cuttle-fishing. So have you done this work?
No, sir, we have read a paper on it. Sir.
You read a paper on that because it involves several procedures.
Yes, sir, we only took one method, that is the MTT assay.
So ethical committee is there. You cannot. So for doing this work,
okay, sir.
We have to go to medical council and all. So what is your innovation in this? You studied these details from a research paper, research article, which was published in which year?
Sir, 2 years back.
2 years back. So what is your idea? You may have some idea. So you can suggest that.
As we know, cancer is the most predominant disease, sir. And also the drugs which we have now has more side effects, because people having cancer treatment are more prone to autoimmune disease, because the drugs affects the normal cell as well. So from the natural extract, we can get more eco-friendly and more natural treatment, so that our body is not affected from the treatment, sir. So I think the process of using nanoparticles has improved the cancer treatment. So
very good. So it is a very important work, but your part should be there. So in this research, so now you are in the PG level. You can extend your studies. You can give you suggest some new ideas and all. So that should be an important point. So any presentation, we need some novelty. Okay, already existing result. Okay, you have studied the literature. So you should give something. Okay.
So, sir, we are thinking of continuing it as a project for in MSc second year.
Okay, so very good, very good. Best wishes.
Thank you, sir.
So next presenter is 78.
Good afternoon all. My project is titled as In Vitro Anti-Cancer Activities of the Herbal Formulation Against Breast Cancer MCF7 Cell Lines. And contents includes introduction, aim and objective, materials and methods, result and discussion, summary, conclusion, references. So introduction, we all know cancer is one of the most life-threatening disease and it needs conventional chemical treatment. But in our project we have used 4 medicinal plants to therapeutic use of anti-cancer activity. Our aim is to research anti-cancer study and activity using 4 medicinal plants, namely Sorelia coralifolia, Curcuma longa, Melia dubia, Camellia sinensis, and to know their synergetic effect. My objective is to prepare ethanolic extract of these 4 medicinal plants to evaluate cytotoxicity tests and anti-proliferative assay using MCF7 breast cancer cell lines to formulate combined herbal extract and to show their highest cytotoxicity level to assess their synergetic effect of these herbal formulation. Materials and methods, sample collection. We have used 4 medicinal fresh plants and make it into powder form. Using ethanol, we have extracted the medicinal plants and incubated for 48 to 72 hours. We have done phytochemical screening to detect various secondary metabolites and anti-proliferative activity through MTT assay and DNA fragmentation. And results, we have taken 4 medicinal plants, and these 4 medicinal plants identified 12 phytoconstituents. Among these 12 phytoconstituents, the 4 phytoconstituents shown higher concentration, which is alkaloids, quinones, phenol, coumarins. And these anti-proliferative activity analyzed using Saccharomyces cerevisiae cell lines. Based on cytotoxicity result, our plants combination is named as 4:3:2:1 ratio. Because we have used 4 medicinal plants, which plants has higher activity. In this basis, we have given this ratio of herbal formulation, combined herbal formulation. In MTT assay, we have done cytotoxicity effects, and DNA fragmentation, we all know for indicated apoptosis. And these 4 combined herbal formulation has higher anti-cancer potential and existing anti-cancer properties. And for further studies, we have to elucidate mechanism of action. This is our DNA fragmentation band formation, and that is MTT assay results. At various concentration, the cytotoxicity results were shown as bar graph. These are the references. And thanks.
So questions from the audience? So can you explain about what you have done? So
First of all, we have taken 4 medicinal plants, so like turmeric, babji seeds, green tea, and neem leaves. We have done ethanolic extraction, and we have done MTT assay and DNA fragmentation to know how the programmed cell deaths were inducing by this formulation, combined formulation.
okay, you have shown some bar diagram, that cytotoxic activity. So what do you infer from that?
So at various concentration, at different concentration, how the programmed cell death get inducing, that only we have shown in bar graphs.
Okay, thank you.
Thank you, sir. Thank you.
So BM79.
Good evening, everyone. We are honored to represent the phytochemical analysis, antioxidant and gas chromatography, mass spectrometry profiling of Costus igneous plant. Costus igneous plant is also known as an insulin plant. It is present on the Subraja and Emineshwari, Dr. NGP College, Arts and Science College and the Coimbatore. The content is an introduction, aim and objective, materials and methods, results and discussion, bibliography. Introduction. Costus igneous plant is also known as the medicinal plant. It is traditionally used to manage the diabetes. It is composed of the bioactive components, flavonoids, phenols and etc. And the bioactive components that are antimicrobial, antioxidants and anti-inflammatory disease. Aim. It is exposure to evaluate the phytochemical composition, antioxidant and anti-diabetic potential of the ethanolic extract of Costus igneous leaves. Objective, it is performed to the phytochemical screening of Costus igneous leaf extract, determine the total phenolic and flavonoid content, assess the antioxidant and anti-diabetic activities. Bioactive compounds through the gas chromatography, mass spectrometry analysis and relate them therapeutic effects. And sample collection and preparations. First of all, fresh sample contraction, Costus igneous leaf collector and shared dried the powdered extractions. Extraction solvent is carried out the ethanol extraction, analysis and performed. Phytochemical screening. Phytochemical screening that is detected to components of the phenols, flavonoids and etc. DPH assay, antioxidant assay. It is used to test the bioactive components. DPH is a radiation scavenger. It is a phenol components that are the quantitative to estimate the phenol, total phenolic components. That are the two methods, total phenol and falling cultured method and the total flavonoids, aluminum chloride method. And gas chromatography and finally gas chromatography and mass spectrometry. It is used to identify the bioactive components for the sample extraction. And result and discussion to continue, Subraja.
So good evening everyone. On continuation with results and discussions, first phytochemical screening. So phytochemicals, the phytochemicals which have present in the Costus igneous plants or alkaloids, flavonoids, steroids, terpenoids, tannins, phenols and proteins. These are secondary metabolites also. So these are extracted in our lab. We have done this. So next, antioxidant activity. The antioxidant activity is deducted by the DPPH assay. DPPH means nothing but diphenyl picric hydrogen. So this assay is used to detect the activity of antioxidant. So why in insulin plant, why antioxidant activity is rich? Because insulin level, insulin cells gets damaged by higher oxidative stress. So to reduce these oxidative stress, the antioxidant activity have performed. So this activity is detected by DPPH assay. So this method measures, as I already told, that measures the ability of antioxidants to donate hydrogen and neutralize the stable DPPH. The absorbance we have observed in 570 nanometer. So this is the graph which represents the concentration over the free radicals, the antioxidant activity. So next is GCMS profiling. All are well known with this heading, I think so. So GCMS is nothing but gas chromatography and mass spectrometry. So this analysis was performed in HP5MS column. So methanol extracts are filtered and injected using a helium as a carrier gas. So next, the last summary and conclusion. So why these tests are taken by us? Because we revealed that this insulin plant, this Costus igneous plant has anti-diabetic property as well as anti-inflammatory and antioxidant. So by taking these plants as our
as our source, it can reduce our insulin level. Most of the type 2 diabetic patients can using this leaves to reduce their glucose levels. So the extracts also exhibited significant anti-diabetic potential, and GCMS analysis identified bioactive compounds are responsible for the antioxidant activity. Okay, these are the references and acknowledgements we have used. Thank you.
So what is the application of your work? So where it can be applied?
So we have applied for using for diabetic patients. Diabetic patients can use it fresh leaves or in powder forms or in juice forms. So we can use it to reduce our insulin levels. Like Ayurveda, so like that, sir.
Okay, ma'am. Thanks.
Thank you, sir.
113.
Angela Lindsay, sir.
Good evening, sir. Good evening, one and all. I am Dr. Angela Lindsay, Research Associate representing VMRF Medical College and Hospital, Salem. The topic of my research work is fucoxanthin, a magic compound from Padina pavonica, extraction, characterization, and the therapeutic applications. This is the original research work. The aim of their work was to find out a multipotent drug which is capable of dealing with the diabetes, obesity, and inflammation, which are the three major crises in the current society in present scenario. So the fucoxanthin compound was extracted because it is a compound which belongs to the xanthophyll group. It has been globally reported in the course of Japan, Korea, and China so far. But here in our study, we have extracted the compound fucoxanthin from Padina pavonica, which was sourced from Tamil Nadu in the Pamban coast of India. So that is these are the objectives of the study: sample collection, morphological identification on confirmation of the compound fucoxanthin from Padina pavonica, and structural characterization using these analysis, and application for hyperglycemic, hypercholesterol, in CA ligand studies, and anti-inflammatory work, concepts for albino mice. So first, for extraction, the agar samples were collected from Gulf of Mannar region in the Pamban Dam nearby. It was dried in room temperature and was frozen. So this is how the fresh sample of Padina pavonica looks like. It is identified morphologically because with the help of the rhizoid fan shape, which is a thick membrane-like texture, the frozen sample looks like this. Extraction and purification. The extraction of the compound fucoxanthin was done using column chromatography in methanol and a combination of hexane and ethyl acetate in a silica gel with mesh size of 60 to 120. And in the different combinations of hexane and ethyl acetate, the 5:5 was optimum for fucoxanthin extraction. It was a reddish orange pigment present in the column.
and it was characterized, after extraction, it was characterized to confirm whether it is fucoxanthin or not, for which we bought fucoxanthin in sigma grade, and we did TLC analysis to compare. There are two methods. In normal TLC, we are able to find a light orange band, whereas when we expose it to UV, we find a dark gray-like band. And further, for confirmation, TLC is a very basic analysis, so for further confirmation, we used UV spectrum FTIR. In UV spectrum, we obtained the spectral using the standard fucoxanthin of sigma grade and the extracted fucoxanthin from our sample. In HPLC analysis also, the same was performed. We were able to obtain similar band patterns with the standard fucoxanthin obtained from sigma and the fucoxanthin extracted from Padina pavonica. FTIR also was performed to find out similar functional group analysis from the standard and the sample. Most like 70 to 75% of the functional groups were similar to confirm the compound is actually fucoxanthin. The applications, as I said before, for hypercholesterol, obesity and anti-diabetic activity, the applications were performed using C. elegans. So the growth conditions of the nematodes are mentioned here. I'll go a little fast because of the time. And for hyperglycemic study, while inoculating the worms itself, we were giving glucose solution in 100 and 200 millimole per liter concentration. They were allowed for 1 day, 24 hours, after which 10 ml of fucoxanthin in the concentration of 50, 100 and 200 microgram per ml of DMSO. DMSO is the medium. Were given. The control group was as such maintained with with the glucose induced, no compound treated, and the rest were like compound treated in 50, 100 and 200 microgram per ml. So AH compounds were detected. AH are advanced glycation end products which are formed as a result of the non-enzymatic reaction when there is induction of glucose in the nematodes. So based on the obtained based on the H compounds formation, we perform high content screening. When age is accumulated, the high content screening assay shows fluorescence, which is attributed to the increased number of fluorescence to the increased glucose concentration. So this is the high content screening results. This is bright field imaging. This is bright field and fluorescence imaging. This is actually, it's not clear, sir. This is the fluorescence imaging. In normal, we were not able to detect any fluorescence. This is a medium induced. There was also no fluorescence. Whereas in only 100 millimolar glucose induced, there was fluorescence observed. In 200 glucose also, lots of fluorosed nematodes were observed. Whereas when we treated with F50, which is fucoxanthin in 50 microgram concentration, there was a significant reduction. Then 50, 100 was much reduced. Then 100, this also 100. Then 100, 200 was very much reduced. In fact, in 200 microgram fucoxanthin treatment, there was no fluorescence at all, which means it is able to reverse the formation of advanced glycation end products. So this is the spectrophlorometric analysis which was performed with the nematode extract in the supernatant alone. So we were almost able to, these are the medium, green line is a normal. And F100 is fucoxanthin treated in 100. When there is glucose induction, the intensity is almost 25, but when it is treated with F100, it is almost equivalent to normal. Similarly, in 200 millimolar also, when there is glucose induction, the intensity of fluorescence is very high, whereas it is treated with 100 and 200 of fucoxanthin, there was a significant reduction in the fluorescence, which means it is able to reverse age. The nematode extract DNA assay analysis result also, this is glucose induced, treated with fucoxanthin, there is a reduction, which is very significant, which means that the compound has anti-diabetic properties. Coming to hypercholesterol activity, the medium was given with high cholesterol supplement while in the L1 stage itself, and after that lipid accumulation was observed using Nile red staining and fluorescence imaging. When there is Nile red, when there is a liquid accumulation, the Nile red is able to stain the lipid bodies so that the fluorescence is directly proportional to the amount of fat accumulated. This is bright field and fluorescence imaging. This is a normal one where there is no induction of cholesterol. Here is the 25 mg per liter cholesterol induced. There were few cholesterol lipid bodies which were observed, whereas after treatment with the compound, it was almost equal to the normal, which means the compound has the potency to reduce the lipid bodies which are accumulated. DAF2 and DAF16 gene expression study was performed using semi-quantitative PCR studies. These two genes are indirectly influencing fat accumulation. This is the primer which we use. Beta-actin was the housekeeping gene, the PCR conditions. So we were able to obtain the normal, high cholesterol and compound treated category. This is for DAF2 gene, this is DAF16, and this is the housekeeping. So based on the gene expression analysis using ImageJ software, we were able to quantify this. This is a normal DAF2 and DAF16. When cholesterol is induced, there is a increase in the formation of DAF2, expression of DAF2 gene, whereas after treatment, the DAF2 and DAF16 gene regulation has been down-regulated by up to 1.2 or 14 folds. The final one is the anti-inflammatory study which was done in mice model. We were able to induce inflammation in the hind paw of cis albino male mice. There was a formation of, we induced carrageenan to the mice so that there was paw edema, which was observed with reddishness, swelling and pain. So we were treating with aspirin, which is a commercial anti-inflammatory drug which is available in the store. This is the vector in which the fucoxanthin was given, which was DMSO. F1 and F10 are 1 and 10 mg of fucoxanthin based on the body weight. So we were able to find that there was a reduction in the inflammation also. So to summarize that, fucoxanthin compound has effectively reduced anti-diabetic activity and has also been observed to reduce anti-inflammation. So this has been discovered or found as the multipotent drug. Thank you so much.
It's very good, madam. So your compound is active in reducing sugar level and cholesterol level, is it correct?
Yes, sir.
Okay. So I am from different background. Okay. So have you published any research articles?
We have also performed NMR and some other assays are on the way after
so
that.
So some more assays are there.
Yes,
okay, very fine, very good.
Thank you, sir.
So next 112.
Good evening, everybody. I am Dr. Raj Shekhar from Variyar Medical College. My work. Okay. Sir, actually it is an in vitro study that is a novel compound, flavonoid compound, hesperitin, that inhibits the cell inflammation growth and it induces apoptosis in KB cells, oral cancer cells, through the mitochondria mediated pathway. So generally there is a definition for cancer that is uncontrolled division, collection of related diseases and a group of more than 100 diseases. Actually interesting definition I noted here is the evolutionary definition of cancer, where cancer is driven with somatic evolution that escapes the control of replication. Actually, it is a cell-press published paper. So it is interesting to study about cancer after studying this definition. And generally, cancer is the second leading cause of mortality next to cardiovascular diseases. And in worldwide, nearly 450,000 are exceeding yearby. And in India, nearly 236,000 new cases are totally related with tobacco consumption. And in oral cancer, nearly 90% seems to be squamous cancer, squamous cell carcinoma. In South Asian countries like India, Pakistan, Bangladesh and Sri Lanka, the prevalence is more. The oral cancer symptoms are wounds in the mouth, with patches, a sore throat and the numbness. You can observe here. And these are all the risk factors for the oral cancer: the chain smoking, excess alcohol consumption, tobacco chewing and unnecessary implantation too. And human papilloma virus is also a reason for this oral cancer. And the treatment is actually, it is very limited actually. Mainly chemotherapy is a present condition and surgery is in the early stages and radiotherapy is also very limited. So this is my compound actually, hesperidine actually, it is different from hesperidine actually. Both are flavonoid compound. It is a A-glycan compound. That is, this hesperidine is from the hesperidine actually. It is a simple sugar molecule. And also it possesses many activities like antioxidant and inflammation activities. And my objective is the cytotoxic effect and to study the intracellular ROS generation by hesperidine and the membrane, mitochondrial membrane potential and morphological changes in the KB cells and DNA damage and some inflammatory and apoptotic markers. When coming to the cytotoxic activity, the hesperidine we introduced 10 to 15 micromolar concentration. In that 10, 20 and 30, 30 seems to be effective actually. In ROS generation, the control cells shows the weak fluorescence, whereas the 10, 20 and 30 shows the high fluorescence levels that shows the presence of ROS generation in KB cells. And when coming to the membrane potential is actually important for the protein transport in the cell. So in control cells, it is very intact, very normal, but in other cells like 10, 20 and 30, the membrane is totally, potential is totally disturbed actually. And when coming to the morphological changes, here we studied dual staining actinic orange and ethereum bromide study. In actinic orange, when we treat actinic orange, the green live cells will be visible, but it's not with the dead cells. Whereas in the ETBR, ethereum bromide, when we treat ethereum bromide, it won't attach the live cells. It will, okay. It will attach only the dead cells like early and late apoptotic cells and necrotic cells. And when coming to the nuclear condensation study, because it is a nuclear study, because in nuclear damage studies can be confirmed by the blue fluorescence by the DAPI staining actually. And for the common assay, it is a single cell gelide electrophoresis. When the agarose and salt is treated with the cell, there is a big change in the pH that results in the movement of the cells actually here. Movement of the DNA head actually. Like this is a normal one, this is 10, 20 and 30. And coming to the inflammation apoptotic markers actually, here we can see the inflammatory markers have been inhibited, but in apoptotic markers have been induced in this condition. So what we conclude is hesperidine is an excellent flavonoid compound like hesperidine and diosmin, which is effective for cancer, anti-cancer activity. So this will be effective and novel compound for our future work in animal study and other studies. Because in chemotherapy, while giving the chemotherapy, sir, actually I have studied a paper, they have, along with the drug, they are giving hesperidine and diosmin as a supplement actually. There they have observed a good results. That's why our novelty is, our finding is, we have to give this hesperidine along with the current drug like pembrolizumab and cisplatin like that. These are my references and thank you.
Have you published the research findings?
Sir, actually, we have to go for the animal study actually. Okay. For that, we have to do that, then only we will go for publication.
Okay, sir. Okay.
Thank you, sir.
Good evening, one and all present here. I wholeheartedly welcome you all for this ANRF sponsored Indo-South Korea Thailand 5th International Conference on Nanoscience and Nanotechnology for Energy, Environment and Biomedical Applications. Jointly organized by Vinayaka Mission's Kirupananda Variyar Arts and Science College, a Constituent College of Vinayaka Mission Research Foundation deemed to be University, Salem. Core Facility Center for Photochemistry and Nanomaterials, Research Institute for Advanced Chemistry, Gyeongsang National University, South Korea. Department of Chemical Engineering, Chulalongkorn University, Thailand. I cordially invite you all for this iNEEBA-2025. I welcome all the eminent speakers and guests from all over the country. It's our delight to invite the guest of the day, the management, respected chief guests, guest of honor, university officials, registrars, sir, vice chancellor, sir, deans from various institutions, head departments, mediculous faculty members, last but not least, our enthusiastic participants who are agreed to share their precious time with us. Once again, I welcome you all for this valedictory function, iNEEBA 2025. The journey of 1,000 miles begins with a single step. A noble philanthropist and educationalist, Tirumuruga, Kirupananda Variyar, Tavathiru, Sundara Swamigal Medical Charitable Trust in the year of 1981, with the heavenly blessings of Dr. A. Shanmugasundaram, Founder Chancellor, with the benevolence of Mrs. Annapurni Shanmugasundaram, Madam Founder Chancellor of Vinayaka Mission's Research Foundation, deemed to be University. The pedestal of Vinayaka Mission's Research Foundation, deemed to be University, Dato Sri Dr. S. Saravanan, President of Vinayaka Mission Research Foundation, Dr. A. S. Ganesan, Chancellor of Vinayaka Mission's Research Foundation, deemed to be University, Mr. N. V. Chandrasekhar, sir, Vice President of Vinayaka Mission Research Foundation, deemed to be University. With the showered blessings all of them, we begin this valedictory function. A smile is the universe. Welcome, the essence of welcome, is making a people feel unforgettable moments. Through this hard work and dedication and sincerity, one can earn respect. May I invite Dr. M. Prakash, Head Department of Computer Science, to deliver a welcome address.
Good evening to one and all present here. It is a great privilege and pleasure to welcome you all to the valedictory function of the Indo-South Korea Thailand 5th International Conference on Nanoscience and Nanotechnology for Energy, Environment and Biomedical Applications. Organized by Vinayaka Mission's Kirupananda Variyar Arts and Science College, Vinayaka Mission's Research Foundation, deemed to be University. At the outset, I express my heartfelt gratitude to our respected Founder Chancellor Dr. A. Shanmugasundaram and Madam Founder Chancellor Mrs. Annapurni Shanmugasundaram for their constant encouragement and blessings. With the deepest respect, I extend my warm welcome to our beloved Chancellor Honorable Dr. A. S. Ganesan, sir, whose visionary leadership and continues inspire academic and research excellence across all our institutions. It is my great pleasure and extend a special welcome to our distinguished chief guest, Professor Dr. A. Anvuchelian, Principal, Annapurna Engineering College, who has graciously considered to deliver the valedictory address of this conference and support for this event. I welcome you, sir. And then I would like to welcome our respected Principal and Convener of iNEEBA 2025, Professor Dr. V. Anbalagan, sir, whose leadership and vision have ensured success of this international event. I welcome you, sir. And then I would like to welcome our Vinayaka Mission's Kirupananda Variyar Arts and Science College Development Officer and Head Department of English, Mr. B. Dasaprakasam, sir. Welcome you, sir. And then I would like to welcome Head Department of Chemistry, Dr. Ganesamurthy, sir. I welcome you, sir. Finally, I extend my heartfelt welcome to all the faculty members, organizing members, research scholars, students and delegates for their active participation and contribution of this successful conference. Once again, I warmly welcome you all to the valedictory function of iNEEBA 2025. Thank you for opportunity given.
Thank you, sir. May I invite Mr. B. Dasaprakasan, Head Department of English from Vinayaka Mission's Kirupananda Variyar Arts and Science College, to honor a dynamic and enchanting principal of Annapurna Engineering College. Thank you, sir. Opportunities are like sunrise. Opportunities multiply as they are seized. Tomorrow may never come. Today, take the opportunity. Be ready to embrace the unexpected magic of opportunity. It's time to announce Best Paper Award and Chancellor Award for iNEEBA 2025. May I invite Dr. E. Shiny Joy to announce the Best Presenter and Chancellor Award of iNEEBA 2025.
First, let us see the oral and poster presentation, Best Presentation Award. They are given under 3 categories: energy, environment, and biomedical application. And the best presentation goes to Mr. Priyadarshan and team, VMKV Engineering College. Next presentation goes to Mr. S. Giri, Dr. NGP College. Mr. S. Giri from Dr. NGP Arts and Science College. Next prize goes to Ms. Jasmine and Momita team from Vinayaka Mission Engineering College. Mr. S. Arif, KPR Institute of Engineering and Technology. Ms. M. Jeevadharani, SAS Chennai Campus. Ms. M. Tamilarasi from Nyanamani College of Technology. Ms. M. Tamilarasi from Nyanamani College of Technology. Ms. K. Karthika and team from Anjak, Sivagasi. Ms. K. Karthika and team, Anjak, Sivagasi. Dr. R. Parameshwari from Tiruvallur University. Mr. V. Kamal and team, VMKV Engineering College.
Come soon.
Ms. S. Aishwarya from PSGR Krishnamal College. Ms. Shirley Shrina and Akshay Kumar from Dr. NGP College. Ms. Jasmine and Momita from Vinayaka Mission Engineering College. Ms. J.P. Shanmati from Vinayaka Mission College of Pharmacy. Ms. E. Gomati, Vinayaka Mission Engineering College. Ms. S. Vanita, Erode College of Pharmacy. Ms. S. Vanita, Erode College of Pharmacy. Mr. Jobbins John Chiria from Vinayaka Mission Kirupananda Variyar Engineering College. Ms. J. Hemalata, Vinayaka Mission Homeopathic Medical College. Dr. N. Shanti, Vinayaka Mission Homeopathic Medical College. Thank you, sir. Next, we are happy to announce the Chancellor Award for this iNEEBA-2025. They will get the cash prize of rupees 3,000 under 3 different categories. Dr. K. Kasturi from Meenakshi Medical College Hospital Research Institute gets the cash prize of rupees 3,000 and a Chancellor Award. Dr. K. Abhisha A. and Afsana Sahin Bono gets a cash prize of rupees 3,000 and a Chancellor Award. Next prize goes to Dr. Vetrivel Arul, Vinayaka Missions Homeopathic Medical College and Hospital, Salem.
Thank you. Thank you, sir. On behalf of the institutions, we congratulate all the prize winners. Feedback is the breakfast of champions. The best way to serve the society is being example what you wish to see in the world. May I invite the participants to share your valuable feedback. Thank you. Thank you for making ordinary moments extraordinary. Thank you for being a ray of sunshine, even on darkest day. Simplicity in living, tolerance towards others, and rooted in humanity. May I kindly request Dr. R. Ganesamurthy, Head Department of Chemistry, to propose a vote of thanks.
Good evening to one and all present here. As we know, a single hand never makes sound. So to get very big clap, we need thousands of hands. The big clap is going to Dr. V. Anbalagan sir, the man behind the very successful event of to make this as a very big successful event. Please kindly give a big clap to Dr. V. Anbalagan sir and Dr. M. Prakash sir, because they and our research team members and all our faculty members of VMKV Arts and Science College who contributed too many things, and they lost their sleepless nights. They served as a sleepless night. Okay. They did many effort. They put their most effort to make this event as a grand success. First of all, you can't construct a building without making the pillar. So we did this event as a very successful because of our VMKV, sir, Annapurna Engineering College principal, our dynamic Annapurna Engineering College principal, Dr. V. Anbuchalian sir. So on behalf of our VMKV Arts and Science College, we show our heartfelt thanks to our principal sir, because as we asked to conduct this program, It's a very big auditorium. You see, it's a very excellent auditorium in Salem, in and around Salem. He made this an auditorium is very excellent for all purpose. Okay. So on behalf of our VMKV Arts and Science College and iNEEBA organizing committee members, we want to show our biggest gratitude to our Annapurna Engineering College principal. Thank you so much, sir. Thank you so much for your support throughout the conference from day 1 to till now. And then next, I want to show my immense pleasure to and thanks Dr. A. Sanmugasundaram sir and Annapurni Sanmugasundaram and our foreign speakers. We want to show our we had 15 sessions. Out of this, all the keynote speakers and invited talk members came and gave a wonderful session. So on behalf of our team members, we want to show our gratitude. Next, participants. Without participants, we can't make a conference as a very, we can't think about a conference. So, Anusuya madam, who contributed more than 70 students from Annapurna Vinayaka Engineering College. So, on behalf of our college, we are showing our gratitude. Next, think about Pharmacy College and Sridevi madam and NGP College. NGP College, they supported 30 students out of, it's a very big support from NGP College. PSG Krishnamal College, 18 students, they came from PSG Krishnamal College, VIT University, even IIT Madras, so many institutes, Nanamani College and Anjak, Sivagasi. They came from very far distance, Anjak, nearly 10 students, they came from Anjak and they stayed together 2 days for, they make this conference as a very wonderful. So on behalf of our committee members and all the juries and session chairs, whoever contributed to make this event as a very successful, I want, on behalf of the core committee, I am going to give my sincere thanks to on behalf of our VMKV principal, VMKV Arts and Science College. So, sir, thank you so much. Thank you so much once again. Thank you to one and all. Thank you, sir.
Thank you, sir. The power of national anthem unites us. Let us end this event with national anthem. I kindly request you all to stand for national anthem.
Shama